You are live. All right, we're live. Nevertheless, do you know why I say nevertheless?
Because it's Asian people over
Yeah,
here.
that's what they say. There's a YouTuber I used to listen to for my studies, and that's how we used to talk. Nevertheless, oh my god, that's like, how can you ruin English so much? It's like, why? Oh my god, they're so funny. Asians are so funny. But Asian chicks are the hottest things in the universe.
Is that true? I don't think they're attractive.
Um, so yeah, maybe at your age I didn't pay attention, but as you get older, like I'm very old, as you know. I'm basically
Are you actually? I could not
actually
disclose that information.
actually yeah.
Are you?
Well,
You are old.
I'm oldish. I'm many multiples of your age. Many multiples.
Many means over three, so
Yeah, many is like more like 100.
yeah, so you're 1900 years old.
That's what they say, you know. That's what they say. Nevertheless, oh, we're streaming. I forgot. I forgot we're streaming. Behold.
I doxed myself recently.
What do you mean you doxed yourself recently? You doxed yourself like I saw your face and everything.
Yeah, no. I gave my full name.
Nevertheless.
Yeah, full name.
So okay, but every bit of information that you give away.
I think that's enough information, considering the fact that my last name is like very unique. There's no one who has my last name and first name.
Hmm. Nevertheless. Um okay, so behold. So do you understand? Do you or do you not understand entanglement? What it comes to say? What is the entanglement? What do you know is entanglement? What have you understood thus far in your lifetime? What's your opinion? What do you think is entanglement? What is that thing?
Spooky action at a distance.
Okay, okay, that's a good start. Go on.
It's nonsense.
Well,
I don't know.
I mean, to say that something has no sense. I mean, first you have to. I mean, you have to make your case. Make your case. But first, what do the other guys say is entanglement? What do the people that believe, let's call them the entanglers? It's actually Bohr. We know him by name. It's Bohr. So Bohr believed in entanglement, whereas Einstein and Schrodinger didn't. So what's the story? What is entanglement? Why? Where did it come from? This entanglement. What is this entanglement? What's the story? And I'm really asking because I honestly don't know. I don't even know what entanglement what they're trying to say because I give up. It's such nonsense that I've given up on trying to understand what they believe. It's such nonsense. It's nonsense to that level that I've given up on trying to figure out.
Super nonsense.
Exactly. Exactly. Nevertheless, so um what do you know? I mean, right? And they always say entanglement, that's the weirdest and the craziest and right? Or no?
I don't know very much. Okay,
I don't know very much either. And I know more than literally everyone on the planet right now. I am.
that's true. Yeah, you're a genius, as I say.
No, I'm not a genius. I'm definitely not a genius, but I've dedicated the last 48 hours to this nonsense, so I've become the world expert on it, whether I like it or not.
That's true.
Nevertheless, So
How do
let's.
I become like you, Mr. Slave?
Well, I became like me.
Are you good at math?
Mm, I cannot disclose that information.
What? You That's true. Okay, that's nonsense. Can you do calculus like calc 1, calc 2?
Well, you can see my videos. You.
I cannot disclose that information.
I cannot disclose the information that is in my videos from this morning.
Yeah, yeah.
You can watch me watching videos. Like I'm start like Veritasium just did a video about the least the principle of least action. Have you ever heard of that?
I haven't watched the video, but it's in my recommended.
But okay, but have you ever heard of the principle of least action?
Uh, I think so. Yeah.
What do you know about it?
I mean, I said I've heard of it, but I don't know
Oh,
what it
okay.
is.
Anyway, so how can you judge me if I know what I know? I mean, you're welcome to try and judge me or test me. Go ahead, test me.
Uh,
Like I'm trying to show you. Okay, let's. I watched a video by Veritasium. You can watch me watching it in real time and following the math
it actually seems kind of fun.
with an emphasis on the word kind.
What? co- What? How's it not fun?
Because I explained in the video, he skips steps. I hate it when people like he skips like
Do you watch it in 2x speed?
I watch everything in 2x, I think. Like almost everything. Like maybe the last video, but like yeah, you know that I watch everything basically in 2x. I told you already. But watching in 2x doesn't mean that I don't repeat again and again and again. If sometimes I feel something it's too fast and I can't track it, then I slow it down to normal and I listen to it. Especially if it's like math or physics. Sometimes the derivation is very straightforward, and they don't skip steps. But sometimes they skip steps, and sometimes they do even worse. They wave hands, and sometimes they do even worse. They're wrong. Then you're like you scratching your head and you're trying to think. Wait a minute, this doesn't add up. And then you're sitting down and you're thinking, okay, why am I getting bad vibes? Like I did with entanglement. Like why am I getting bad vibes? Like I feel dumb. You in the beginning somebody tells you something and they're like, well, 1 plus 1. Since we know that 1 plus 1 is 3, and there are 4, and you're like, what? I don't know what. And then I mean, obviously they never say since we know 1 plus 1 is 3. They say something much more subtle, like incorrect infinitesimals and stuff, or or they skip a proof. They say, "Oh, this this is 0, then this must be 0." No, because I happen to have watched another video where they went through diligently the proof. So what was amazing about the principle of least action? I've watched already a couple of videos, and one of the videos I watched was like an actual mathematician. And when an actual mathematician derives the principle, he actually goes through the proofs, and then you see how a proof is really very straightforward. Like when you actually see a proof, oh, that's really simple. It's like uh, I'd have to watch it again and try it out myself and explain it maybe, but you know but at least you're aware of the fact that you need to prove this point. You can't just assume it. But then you watch Veritasium, and he just Hear me, Gamma. Can you hear me, Gamma? Can you hear me?
Hello?
Yeah, yeah. I don't know what just
Yeah.
happened. I don't know. I saw it disconnecting, reconnecting. Hold on, I need to just close the door for a second. Give me one second, please. Are you there?
Yep. Yep.
So the point with math is that when you watch a lot of YouTube videos, they skip steps. So
That's true.
you
Yeah.
would think, oh, they're skipping the hard part.
I feel stupid a lot when
Exactly.
I try and learn math, and I think I am slightly below average IQ, but like, you know,
No, you're not. No. So
I feel it.
so when you watch a YouTube video like Veritasium, you might feel dumb because he's wrong. He basically says 1 plus 1 is 3, and based on that, he goes to the next step. Basically, I mean, he doesn't he doesn't prove. I mean, so I was watching a mathematician derive. The Lagrange. At the end of the day, you need to derive the Lagrangian. So so I watched him derive the Lagrangian, and as he was deriving it with all the proofs, like he was going through the nitty gritty, diligent steps, he kept saying, "We're gonna hand wave." And we're gonna approximately, we're not really gonna prove. This is just, we're gonna pretend we're proving. And he was proving things that finally, like finally I see what it means to not skip steps. So it was like an hour or 2 hours of proofs, but it ended up being better than 5 minutes of hand waving and skipping steps that I can't follow and I feel dumb. Do you understand?
I do understand. Yeah.
So a lot of times, like even I'm guilty, we're all guilty of this. So when we're explaining something to someone, we're skipping steps, and sometimes we're not aware of it. Sometimes we are aware of it, but we want to fool the other guy because we want to feel smart. Like, I don't want to tell you I don't understand something. I don't really understand the derivation, but I don't want to tell you I don't understand the derivation. So I pretend to understand the derivation, and I fool you, but you end up feeling dumb. You end up feeling that you don't understand the derivation, and you're correct that you don't understand the derivation because my derivation is faulty. But the teacher has this advantage that the students usually have no clue if the teacher understands or doesn't understand. Like even when I debate people, a lot of times I can't prove definitively that they're lying. It's almost impossible to prove that the other guy is lying.
That is true. Yeah. I've known that from flat earth and everything.
Yeah, it's impossible. Like, is he really that dumb, or does he really believe it, or am I wrong? It's like you honestly don't know because you go in circles. Like I had this, like I have it all the time. That I go in circles with people, and when like tell me what to tell you. What tell me what to tell you to convince you the way I am convinced, and then you start questioning your sanity. Like, well, and like when you think about something too much, you lose it. It's like you like if you say the word much many 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 times, if you think about the word much, you can lose your mind. It's like instead of being a word that you instinctively say from from that part of the brain that has been like it nonchalantly says now you're thinking about it, and now you're confusing yourself. Wait, is the word much, is it really the word much? What it's like when you think anyway, when you debate someone, it's like you're starting to question, like you losing. Anyway, so and you don't know if the other guy is lying or not. Like, what are you doing wrong? Like you're trying to convince someone 1 plus 1 is 2, and he says no, it's 3. But like, or you feel that you convinced the other guy that 1 plus 1 is 2, and he says, well, I'm not convinced. What do you do with that? Like, is he really not convinced, or is he lying, or is he mentally insane, or am I wrong, or did I prove incorrectly? Did I not? There's so many options. So so imagine the student with the teacher. The student has no idea that the teacher is bluffing. That the teacher doesn't know the derivation. The student has and even if the student knows that the teacher doesn't know the derivation, there's nothing a student can do. So you're watching a YouTube video where veritasium does a derivation, and there's no way you can consume it and survive. You're like, I don't know. Anyway, that's as much as I have to say about the psychology of math. Anyway, what are you doing?
What? Oh, I'm
Mm-hmm.
I'm looking at a
Mm-hmm.
I'm looking myself up right now.
Don't worry about it.
If you were to look yourself up, would you get
I
hints?
cannot
Here, man.
disclose that
What? That makes
information.
no sense. I'm not even. Oh, are you? Yeah, because you're famous.
I don't know. Look, you see what happened to you.
What happened to me?
You nonchalantly gave away information that now is legit bothering you.
No, it's not. I just want to know. Like, I could care less if people.
Fine, good. Let's
Oh,
continue. Let's continue. We have much to do.
but Mr. Slave,
Mm-hmm.
I'm.
What?
What else interests you other than ether?
What are you talking about? I'm talking about entanglement. It has nothing to do with ether.
Entanglement and schmaglement.
That's exactly.
What's something in engineering that interests you?
We can we can legit watch a YouTube video about the least. You want to watch Veritasium's least principle of least action?
What's something in engineering that interests you?
Anything as long as it's it's good engineering. I don't care. Whatever. I'm.
What's your opinion on Starship?
It's unbelievable. I think Elon Musk is the best humanity has right now by far, by a long shot.
Do you think it'll end up working?
Of course. What do you mean? That's
Uh,
Elon
what?
Musk is the best engineer by far on the planet. I mean, if you want to learn engineering, you just need to learn his method. He has a method. You see that Boeing failed where he succeeded. And he's basically a one man show.
I mean, he's not the reason that Starship. Well, he is the reason that Starship exists, and the fact that the funding and everything. But like,
Hmm.
uh, he is an engineer, but the SpaceX people at SpaceX are the ones who are engineering the vehicle.
Yeah, but who hired them? Who you know?
Not Elon. Elon doesn't do all the hiring.
Look, you have Boeing and other failing
Starliner,
engineering.
yeah.
There's many engineering companies that are pooping their pants, trying to do pooping their diapers, trying to do
A
something
fraction.
a fraction of what he has already done many years ago. and they're
That's true.
what?
I said that's true. Yeah.
So bottom line, what is the difference between them and him? The only difference is him, right? Everybody else has this planet available to use. So he is able. If you claim that the difference between let's say SpaceX and Boeing, if the only difference that you can find is Elon Musk, then Elon Musk is the reason for the success, for the difference in the success.
I mean, it's different
Hmm.
cultures at the companies, different objectives. Boeing doesn't want to. They're not interested in colonization of Mars. Like, reason Starship is a thing isn't because um, they want to capture the launch market necessarily. It's because they want to develop a vehicle to go to Mars.
But you could argue about Starship, I'm sorry, SpaceX, but then you would also have to argue about Tesla. It's not, and and then you would also have to argue about Twitter. So it's not like, I mean, it's not like it's his first success. And then you would also have to argue about PayPal. I mean, the guy has success after success after success. So it's not that you can't just analyze SpaceX. You have to analyze everything he's done, his track record, his his life track record. That's what you have to analyze.
But you think Starship will work?
I don't have a doubt, honestly. Why would I, like, why would you doubt? What do you doubt in Starship?
I don't. I don't. I don't.
So what is,
Well, actually, I do.
like, what is there to
I
doubt?
doubt. I doubt the timeline for sure. Um,
What do you mean?
I mean, I think it'll
The
be
timeline
done
right now,
eventually.
the timeline is delayed by Biden and Harris, basically.
What? That's not true.
Well, I mean, it's by the administration, by the FCC, the FCA, the CIA, the Chi, all the three-letter nonsensical. Hello,
Chi
oh,
chi chi.
spaghetti. You know, the three-letter.
Alphabet agencies.
Yeah, I mean, basically terrorist organizations. They should be called, created by our one and only Nixon. I
That's
think
true.
he created most of the nonsense, that idiot.
Yeah.
So,
I mean, I think it'll work, but I don't
mhm,
know. The timeline's
mhm.
pretty bad.
What do you mean? But the timeline right now. They are delaying him.
No, they still need to demonstrate like the launch cadence is that they need to be able to reuse the full system,
Okay, it doesn't matter.
not
What's
just
okay? It doesn't matter.
what.
What's let's talk engineering. I don't like wasting time. So, engineering wise, or the financial engineering? What about Starship? Do you question? Like,
I question the reusability of the start of Starship, the upper stage, which is Starship. We'll refer to that as
why?
Starship.
Why?
Um, well, the atmospheric heating over hundreds or even tens of cycles, like it's unknown of what it's going to do if they can refurbish, and like it's very, very hard to make a reusable upper stage since you're coming in at nearly 8 kilometers per second if you're going from low Earth orbit.
Let's say he doesn't reuse the upper stage. As far as I know, the the upper stage, it's basically steel. It's not expensive. I think it's relatively not
Well,
expensive.
the true, well, not necessarily. I mean, it's 9 meter stage. It's a pretty huge stage. There's a lot of material there, and
Hmm.
takes a while to manufacture. So it takes while to manufacture the parts to put them together. But the most expensive parts each are going to be the engines. I mean,
They make one engine per day. I think they dropped the cost to 250,000 per engine. So
yeah, I
there's just six engines. That's that's
yeah.
about $1 million. It's probably under 250. It was 250K like a year ago. It's probably under 1K. I mean 100K at this point probably. But look, the question is the bottom line. I mean, it doesn't matter
I
if
mean, how wait, 20 million divided by,
it doesn't matter.
let's say if we
It do-
assume 20 million,
it doesn't matter.
100 and,
It doesn't matter. It doesn't matter. The question is, what is the bottom line of SpaceX with Starship compared to without Starship? That's the only question. I think that even if you don't reuse Starship at all, it's still more economical than what's the first one? Nine, Merlin 9. What do you call the 9 one? Falcon
Falcon
9?
9, and this
Yeah.
can't be right. So 20 million
Hmm.
divided by 150,000
It doesn't matter.
is 133. Is that true?
What do you? Look, it doesn't matter. It honestly
Hold
doesn't
on.
matter.
No, no. Wait, hold on. Is that
Mhm.
true?
What? I don't know. I mean, to pull out a
20 million
calculator.
divided by 100, that doesn't sound right. So I say that each Starship upper stage is 20 million for the whole flight, if they expend the Starship, that's $133 per kilogram. That's really low. Huh.
Yeah. Yeah, you don't need to reuse any part in Starship, and it would still
Well, the
be.
booster.
No, I don't
I
think
mean,
you
the
need.
booster you need
No,
to re.
I don't think you need to reuse it. In order to make Starship more efficient than Falcon 9, I don't think you need to reuse anything. It's just and in the long run it's going to be cheaper and cheaper. It's just cheaper materials, cheaper everything. Everything is just cheaper. Right now you're seeing the cost, the design cost, of the factory, and but once that's up and running, producing starships is going to be really cheap. So as far and the engines, everything is streamlined, and you see how they simplified the engines. Look, I don't
Yeah,
know.
yeah.
Look, I just don't know. Like my intuition is that Starship does not need to be reused to be more efficient financially for SpaceX. That's my intuition. Just
I
because
agree, but if they want to do the Mars missions, they're going to need it to be fully reusable.
I honestly, personally, don't care about Mars at all. Like,
Really?
yes, it doesn't. It makes no sense. If you wanna, right? He says that he wants. It's not good to have all your eggs in one basket. That's what he says. Therefore, make humanity multi-planetary. However,
Yep.
the make humanity multi-planetary in order to not have all your eggs in one basket, that's not the most efficient solution. A more
Yeah, it would
efficient
take her to the moon.
solution. What?
Would be the moon.
Yeah, probably, maybe, I don't know. But even a more efficient solution is O'Neill cylinders, for example.
Yeah, yeah.
O-
I agree.
O'Neill, like the last thing you want to do is climb up from one gravity well and fall into another gravity well. Like,
Yeah, the thing about Mars is that it's fairly easy to get out of, hop out of, and
but what? I mean, I don't think so. I mean, but why do you want to bury
yeah, it's
yourself?
like 3 kilometers per second.
Why do you want to bury yourself in a gravity well? Why? I mean, you want to have, right? It makes much more sense to build O'Neill cylinders. It just makes much more
Because you have so
sense.
much, you have volatiles on Mars, you have carbon dioxide in the atmosphere, you have nitrogen in the atmosphere.
You don't.
Like
I
Mars is a great place to live compared
no.
to everywhere else because you have so many. Yeah, you have so many materials locally available to you. Volatiles galore, CO2,
Okay, okay,
nitrogen.
okay. Look, at the end of the day, it's cost benefit analysis. So it's not the most efficient solution. You want to save humanity from an asteroid, then the most efficient solution is not make humanity multiplanetary. That's not the most efficient solution. The most efficient solution is make humanity spacefaring.
Yeah,
That is the most efficient. That's the easiest. That's probably the easiest. I mean, Mars to earthify Mars. What do you call it when they earthify?
terraform
Terraform. When like terraforming, that's gonna take.
will never happen.
I'm not saying it will never happen, but that's like.
I'm saying it'll never happen.
But I don't want to say either way. But it's so difficult. I mean, why would you like? Like we could run like in the background. We can start doing it slowly, but that's gonna take time either way. Whereas building an O'Neill cylinder, so you can, right, especially with with robots that are just now coming online and they're just beginning to gain intelligence, and soon they'll have consciousness, and you'll will be able. I mean, they'll build an O'Neill cylinder in space, so that all that we will need to do is just go and inhabit, just go live there. They'll do everything. I mean, I wrote this program to prove entanglement is false. I gave ChatGPT the instructions. And when ChatGPT didn't build the Python code correctly, I looked at the code and I didn't change the code. I told ChatGPT to change the code. So, and this is ChatGPT, I guess 4 or something. Imagine ChatGPT 40. I mean, this is something that we cannot begin to imagine what it can do. It would easily read our minds. I mean, that goes without saying. So
Yeah, it might be over
what?
for us all. Might be over for us all.
No, I don't believe in that view. So anyway, let's get back to.
Oh, physics
No,
schmizics.
no, no. You said you want to discuss Starship, so that's what you wanted to
Yeah,
discuss. You
I
wanted
agree. Yep.
you wanted my opinion. So my opinion is that Mars. I wouldn't talk about Mars. I find any discussion of Mars to be excruciatingly boring and unproductive. And I think the
Because
design,
Mars.
what?
No, nothing, nothing, nothing.
I think the
Move on.
design of Starship is hampered because it's designed for a landing on Mars. Starship is basically a vehicle for Mars, which is it's a terrible idea because it doesn't serve any purpose. There's no reason to land on Mars. If anything, the moons of Mars are amazing. Those are great places to land on and do stuff with. I mean, I think you can build a space elevator from those moons to Mars, if anything. I think there's so many great projects you can build using Starship, like a space hook or a moon mass accelerator. Or, I mean, there's so many projects you can build to advance humanity. Like even an Earth protective service or protective shield using a mass accelerator from the moon. Imagine, do you know what a mass accelerator is?
Yeah, yeah. Use magnetic fields to accelerate cargo.
Right. It doesn't matter how you accelerate it. You just accelerate it and you shoot mass from the moon. But imagine you can aim it at an incoming. Let's imagine an incoming Oumuamua from interstellar space
Yeah,
that we
yeah.
discover is
Aliens are trying to kill us.
it's about to hit us, and then you can aim this mass accelerator from the moon and shoot dust. That's enough. Shoot dust from the moon at it and blow it up. That's all you need. You don't need much more than that. You don't need to hit it. You just fire some dust at it. It's gone. Nothing will survive this impact. It's just going to blow up like crazy. it will disintegrate instantaneously, which you don't even need to do. I mean, you just need to cause a minute deflection in order to save Earth. So that's like, if you want to save humanity, then save humanity. Don't let humanity die and have a ragtag, like a bunch of us live alone on Mars, and we're probably going to die there because because it's a dead planet, and it's gonna be impossible to survive on, and it's gonna be a gravity well. So if you want to save human, there's so many things you can do to save humanity using Starship. Do you know what a s-
Yeah, yeah.
do you know what a
Space
space
what?
a space hook? Do you know what that is?
Yeah, yeah. You have a long tether, and you have it on, not like you said, on the moons of Mars or
No, that
even above Earth. You could have it above Earth, and you could lift stuff into orbit from the
no,
atmosphere.
no, that's a space elevator.
Well, space hooks are where you can lift stuff into the up into the. You have a counterweight on the one side, and then you have a
That's a space
tether.
elevator. That's a space
No,
elevator.
no.
So what's the
I'm
difference?
describing a space.
What's the difference
Space
between?
elevators are just vertical elevators, basically. Space hooks are in space already, and they don't go on the ground at all. And they have a tether, and then
No.
the hook drops into the atmosphere
Explain.
partially. Yep.
Okay, hold on. So what you're describing is a space elevator. Okay,
No,
then
it's just
explain.
like,
Then explain space
all right,
elevator. Listen. Okay, I'm listening. What's a space elevator?
all right. I'm booting up Paint. Hold on, Microsoft Paint.
No, just pull up a YouTube
No,
video.
no, no, no. Hold on, whiteboard.
Join activity. Activity joined. Activity joined. Join us in this activity.
All right, here's my something I want to bring to orbit. Right.
Something, something, something dark side.
Yep. And then here is
Mm-hmm.
my tether,
Mm-hmm.
and then I have a
Mm-hmm.
something in the middle. I don't know, a joint.
This is an
And then I
elevator?
have a
Space elevator?
nope. This is a tether, and then I have a counterweight weight
Explain.
on one point,
Yeah.
and it's rotating.
What
Yep.
is
So this
this?
is the
What is this? A
yeah.
hook or
This
an
is okay.
elevator?
This is a space hook, and then this is the Earth, right?
Okay, okay. Mm-hmm.
This guy here,
Mm-hmm.
he's not going orbital velocity yet, right?
Mm-hmm. Mm-hmm. What do you mean
This
he's
guy
not
here,
going? I'm
yeah,
confused.
this guy isn't going orbital velocity
I'm
yet, but the
confused.
tether here,
I'm confused.
the
So
tether. This is the tether.
okay, so
Tether.
how does what's in the center? What is that thing that you're pointing at?
This is the thing connecting the
Why d-
counterweight
why do you need a thing connecting? I don't understand.
because it connects the counterweight to
Why do you need what do you mean
the
connect?
tether part.
What do you mean connect? Why is it in one long tether? Why do you need something in the middle?
It was just to visualize. It was just to visualize.
Okay, then erase it.
That it's separate.
Put
That
put
it's
a
separate.
red
Okay.
put a red
Okay.
X on it or
This
delete
is
it.
just to this was just to visualize that it was
Fine.
separate.
Now,
Yep.
so this
This
thing.
is
Wait,
and
hold on. Let me ask questions. So this
yep.
thing is not falling into Earth because
This thing is not falling into Earth because it presumably have station keeping stuff that keeps it in orbit over time. But it would.
wait.
Yep.
So this thing is in orbit.
Yep.
Okay,
Out.
then
All right. One more thing to
wait.
help.
No, let me
Oh,
ask
yep.
questions. Okay, so it's in orbit. So is it moving relative? Is the bottom of the tether moving relative to the surface of the Earth?
Yes. Yes. So it would be there would be this would be moving, right? So there would be a
Why isn't the counter at geostationary so that the bottom would be geostationary?
well, you don't want it to be geostationary. You want it to be close enough to the surface where you can get the tether dipped into the upper atmosphere very, very slightly.
If you're dipping into the
This is
atmosphere at any velocity, you're losing energy or even burning up.
yep.
What do you mean? Yeah.
That's why I said space hook. Space hook, right? This is what a space hook is.
No, it's not. But let me
It is.
no, it's not. So let's go step by step, and I'm trying to use the Socratic method to prove to you that what you're describing is not viable. So let's go step by step. Let's slow down.
All right, I will send a Wikipedia article for you
No,
to read.
no, no. Look, stop, stop, stop. Let's
All right, yep. I
let's
will. I will keep on
let's have a discussion.
explaining how this is viable.
No, no. I'm asking questions. I'm using the Socratic method.
Yep.
So this thing, the why is it not in? Explain to me why you wouldn't want this geostationary.
Well, because then the whole purpose is to have. All right, I need to get back to this. All right, the whole purpose is that um this here this ball that I want to bring to orbit
Mm-hmm.
is not is not in is not does not have enough velocity to get to orbit. It's going to be
Why
traveling.
why give it any velocity? Why not let the tether down all the way to Earth? Have wait, listen. Have this
Yeah.
thing hold on. Have this thing be geostationary. Bring the
Hmm.
tether all the way to the surface and just use it as an elevator. Why not?
I mean, that could be one thing you could do.
Why
Sure.
don't you do it? No, no, why don't you do it? I mean, you basically built everything, so why don't you do it? This is what I'm saying. You're describing a space.
I didn't come up with
This is
this.
not a space hook. This is a space elevator. It's not a space hook. A space
This is
hook.
a skyhook. If you want to look at what I sent in
Okay, I'll explain to
general
you.
chat,
Okay, there's many sky
can you give
hooks.
me 1 minute to explain?
Uh
1 minute to explain.
look, it, a space
1 minute to
elevator.
explain. Just one
Hold
minute.
on. Before that, I'll let you have as much time as you want. But just realize that it's getting close to semantics. So a space elevator and a space hook. There's many space hooks, and you could say that one of them is a space elevator. Did you hear what I just
Are
said?
you done? Are you done?
Did you hear what I just said?
Yep, I did.
Can you
Yep.
repeat what I just said?
Semantics.
Yeah,
It's getting close to
that was
semantics.
the intro, and then I explicated. Can you repeat what I said or close?
Nope. Nope.
So a space elevator is just an edge case of a skyhook. It's just there's many skyhooks. One of them is a space elevator, right? You agree that a space elevator, I mean, it's very similar to a skyhook. There's many skyhooks. One of them, an edge case, is a space elevator. So it's a semantic discussion right now. But if you want to have a semantic discussion, I'm not going to stop you. Go ahead.
All right. While you were ranting on,
You're
I
not
was
listening. Oh my God. All right.
while you were ranting on, I was making a beautiful drawing of how I'm gonna make this.
No, no, no. Come on. Let's hurry up. Our time, like, I'd rather do math and physics than draw drawings.
Okay.
Mm-hmm.
If you look in the Wikipedia side chat,
Mm-hmm.
right,
Mm-hmm.
you can look at how this isn't my idea.
Okay.
You can talk to the guys who invented this nonsense.
Okay, but you know that that is just an appeal to Wikipedia. So you might as well talk to me.
Feel the
What's the
Wikipedia
difference
gods.
between me and them? So,
Uh,
yeah. I'm listening.
it's a tether. It's not a space elevator. It's a skyhook.
I told you an space elevator is just an edge case of a skyhook. There's many
Sure.
there's a
Okay. It's a
spectrum, right? So there's a spectrum of skyhooks. One of them is a space elevator. That's all that it is. But fine, you wanna have a discussion about all the versions. I can have a discussion with you about many versions of a skyhook. My versions. I don't care about Wikipedia. I'll tell you about my versions.
Wikipedia.
Wikipedia.
Yeah. Free encyclopedia.
Nevertheless, so let's continue with Elon Musk. So, as not a space, and a space elevator is going to be very different. The problem with the space elevator is the materials. Like, it's going to be very difficult, if not impossible, to build a space elevator.
I disagree.
Wait, what? No, even go to Wikipedia and look at the strength of materials. You'll see that a space elevator is outside of our domain right now. Even carbon
Yeah, you need.
nanofibers can't sustain the self weight of a simple tether that is geostationary. I mean, it's not. It doesn't even have to be geostationary. Look, I mean, when you get to these lengths with the counterweight, you have to consider the weight of the tether, and nothing that we have right now can sustain itself. I mean, the length of this rope is immense. I don't think this. I don't know if we have the technology for what you're describing, right? Because it's a
The
count.
thing.
It's you're saying it's a
Oh,
counterweight, so the bottom is moving slowly relative to the atmosphere.
well,
You
they would be both moving at the same speed. They have the same radius. So
no, that's
these are the
that's impossible. You can't. That's impossible. You can't have
what's
that.
no. Why can't I have that? If this is okay,
You
you know how
can't.
this works, right?
You can't. You
Let me
can't.
explain.
It you can't.
This is the same length
The orbital,
as this.
but the orbital velocity is not the same. The orbital. No, no, you can't have that.
I can.
No, look at the solar system, right?
I get what you're trying to invoke,
If you tether Earth
but it's
and
different
Mars, no, it's the same. If you tether Earth and Mars, right? You can't tether Earth and Mars. That's all you need to know.
because this is rotating. These are
It doesn't
the
matter
whole
if
purpose.
it doesn't matter.
Mr. Slave, stop
I'm
interrupting
sorry.
me,
I'm
please.
sorry.
Yeah, the whole purpose of the system is that uh this is
Mm-hmm.
this is rotating. So this is moving
Orbiting.
in this direction. Nope. This is the counterweight and the tether are rotating. So there is a
Orbit. What do you mean rotate? Orbit. They're orbiting. They're not.
no, Mr. Slave. The tether is it's pixel.
Oh, good. Very good. That's a good start. Very good. Mm-hmm.
What?
No, it's good. It's good that it's rotating. Yeah, yeah, yeah. That's correct. That's a great version of a space of a skyhook. Yeah.
Yeah, and it wait, this would be opposite direction. It would be like this. There's so much shit right now though.
No.
And this guy is going like, I don't know, 3,000 meters per second or something. And then this guy here is, since he's up in orbit up here,
Mm-hmm.
he's gonna be going faster than that. So what he does is he picks him up and he throws him up higher. You know, that's what I've been trying to explain to you, Mr. Slave.
That's a good version. There's even a better version.
Which is
That as it's orbiting, it's also going up and down. So it dips into the atmosphere when it's not moving relative to the atmosphere. It's bobbing. It's in a it's bobbing relative to its own orbit. Do you understand what I'm saying? Are you
bobbing
listening?
relative to its own orbit.
Right. Imagine an orbit, right?
Yep.
Now have it bobbing relative to its own orbit, right? If you take Earth and you pull it right now away from the sun, just drag it away from the sun, what will Earth do? Not speed it up. Just
It'll
drag
slow
it.
it down.
No, I'm saying you don't slow it down. If you don't slow it down, don't speed it up. You just drag it away from the sun. Let's say I pull the Earth away from the sun by, let's say, 1,000,000 kilometers.
Yep.
What will Earth react? What will be its reaction?
Well, it'll slow down
Why will it slow
a little bit
down? Why will it slow
because it'll
down?
be further from the sun.
But what force is slowing it down?
The fact that it's orbiting over a smaller, or it's orbiting over a greater distance. So it's the
But
circle
that's
or
a,
the path.
you're comparing two stable orbits. I didn't say that I'm bringing Earth to a stable orbit, a million kilometers away from the sun.
Well,
From
if it's a million kilometers further than the current orbit, it has to speed down.
so I'm saying, but I'm not given here. Third grade word problem. Given I take
Yep.
given colon space. I
Yep.
pluck Earth away from the sun by a million kilometers and let it go. What will Earth's reaction be?
I'm not following, Mr. Slave.
What? It's a word problem from third grade.
I don't know what you want from me. What's the answer?
It will bob. It will bob relative to the original orbit. It will. Okay. Draw a
I think
dot.
you need to draw. You need to draw this for me.
I'm too tired to raise my hand.
What are you? Why are your hands in your pants right now?
Stop. Stop. Behold. Let me
Yep.
draw. I'll draw it for you.
Yep.
So this is the sun. This is
Yep.
the Earth orbit.
Yep.
And I pluck Earth away.
Yep.
What?
Nothing. Nothing.
So the Earth will bob relative to its original orbit. It will bob. Maybe it will perfectly bob, maybe not.
Fidget spinner.
Yeah, exactly. It will fidget spinner. That's exactly what it will
No,
do.
I'm
It
saying
will
what you drew. I'm saying what you drew. See, it's a fidget
exactly,
spinner.
exactly. That's exactly what I drew. At least we understand each other. Anyway,
I think I get what you're saying.
nevertheless,
In reference to its original position. Yes.
in reference to its original orbit,
Yes. Orbit. It will bob.
now use this knowledge to create a better, to improve your space, your skyhook. Do you understand?
I think my version is better. I like it more.
Oh my God. Okay. Anyway, we can. Nevertheless, what do you want to talk about? You don't want to talk about math and physics? You want to talk about biology, Darwinism? Why the aliens? You want to talk about why the aliens haven't arrived?
Because aliens aren't real.
What do you mean aliens aren't real?
Uh, they're fake and gay.
Look, Mr. Gamma no hack. Like I'm
They
using
remind me of purple cows.
I'm using your full name to let you know that we're getting serious now.
Yeah.
Mr. Gamma no hack. Now you listen and you listen real good, young man.
Purple cows are better than green cows.
Definitely. Anyway, you want to talk about attractive women?
Women? Yeah, yeah. Can you
Okay.
send me what an attractive woman to you looks like?
What an attractive. I mean, my profile picture. That's a very that's like
Not even a real woman. Is that AI?
I don't know. I found it. I don't know how and when I found it, but it's incredible. I love her. I love her so much. Um,
The fake woman.
I mean, you could say that all women are fake. All men are
That's
fake.
true
Are,
because they
are
wear fake up.
am I not fake? Am I real?
You're real to me.
Okay.
You
Nevertheless,
you don't you don't wear fake up. You know,
why do you say that?
fake up.
Yeah,
It's like a play on words of makeup. You get it?
I get it, but why do you use that terminology? It sounds like you're trying to it sounds like an abusive. Sounds like a little bit abusive.
How is it abusive?
I mean, I find it abusive.
By saying fake, like because women wear makeup and it's fake.
Yeah,
Like it makes them look fake.
like it's not something nice to say. Like if I told you you're fake, would you like that?
Maybe.
Well, usually fake is a derogatory term. Usually.
Usually.
Mostly. Do you remember that little English girl that used to say, mostly? They come mostly at night. Mostly. Remember that?
No,
South Park
I'm
made,
young.
yeah, Do you know South Park?
I know what South Park is, but
Well, there
is
you
that
go.
where Mr. Slave comes from?
Apparently,
Yeah.
that's what I heard. I didn't come up with calling me referencing me as Mr. Slave, so it wasn't my doing. It was somebody else.
Somebody else came up with Mr. Slave.
Yes, indeed.
I usually mop the floor with everyone's face in a debate. Lol.
Yes. So, do you want to hear the story of the debate from yesterday? Do you want to track the gravitanium? What do you call it? Entanglement.
Do you believe gravitons are real?
I'm actually I don't need them because my ether does the job. So,
Oh, Jesse Path of Light is debating flat Earth right now. Gotta go.
all right, I'm gonna go poop.
I
Bye.
love you, Mr. Slave.
I love
All
you
right.
too. Bye bye. All right, I'm gonna go to a bathroom break. In order to commit myself to a bathroom break, I'm going to show you a bathroom break. Wait, you know what? We don't have to. We don't have to. We can share a tab and I can. That's nonsense. I'm gonna poop my pants if I don't go to the bathroom right now. Pooping pants. Pooping pants. Don't think about it. Don't think about it. Oh, that's not it. Loop quantum gravity. Okay, let's listen to gravity. Loop quantum depravity.
Two of the triumphs of the early 20th.
Forget it. We're not doing that. I'm gonna post the bathroom break. It is. It has come to be. Bathroom break. Okay, I'll be right back. Hello.
Hey, Mr. Slave.
Hey, what's up?
I was just streaming this so-called debate between a Glober and a flat earther.
Hmm. Why do you?
Um,
Mm-hmm.
some folks are also over on this Earth Awakenings server,
Mm-hmm.
trying to teach them about theodolites. That's probably far more intelligent than this.
Do you care about flat earthers? Are you a flat earther?
No, no, but I'm just doing stuff and listening to it in the background.
Hmm.
Maybe to feel better about my sad life or something. I don't know.
Interesting. What do you mean your sad life? You have a sad life?
No, that was being silly.
Oh. But are you into flat earth, like debating flat earthers?
I have been, but not lately.
I see. Do you want to debate?
Sure. What you got?
So I discovered, I never liked entanglement from the first day I heard about it. So I wrote a paper, and now I wrote a Python program that disproves entanglement once and for all.
How did you do that?
Let me show you the collab. It's on Google Collab, so you can look at the code.
Are you a software developer?
I don't usually discuss my personal life because I'm trying to stay anonymous. So I don't like I share as little details about my personal life. Nothing to do with like
Okay.
Yeah.
I didn't mean to ask about your personal life. I'm just asking, like, do you have experience writing Python?
I'd rather not talk about myself. Just because.
Okay, but
Mhm.
did you write this Python code? Or did ChatGPT generate it or some AI generate it?
ChatGPT generated it. Yes.
Okay, so you know that ChatGPT will make stuff up, right?
Are you okay? So you can ask me questions about this code. So it's not important where this code comes from. That's really actually irrelevant. So you can ask me questions about this code, and we can debate if this is a legit falsification of entanglement. Are you looking at the code?
Just a minute. Let's
Mm-hmm.
see. Where is it? Live stream chat?
It's in this. No, it's in the side
Oh,
chat. I don't.
V's.
I don't like
Okay.
leaving this chat. I don't see the point. Are you looking at the code?
I mean, I'm glancing at it. I'm not qualified to say whether or not it accurately models
What do you mean you're not
quantum functions.
Wait, if you say you're not qualified, that means you're stepping away from the debate. So you're disengaging from the debate.
I'm not sure that we have a debate going here.
That means
You just asked me to look at some Python code,
that's just
and I'm telling you,
that's just
I
that's just you're disengaging from a debate. When you tell me that you don't know if we're having a debate, that's disengaging from a debate. Either
so
you
like we haven't how can
yeah
this be a debate? We have not agreed on
yes that
a thesis.
yes
We haven't agreed on like anything.
yes
Why don't we just try to have a
yes
discussion? All right.
sure we can have a
Okay,
discussion. I'm just letting you know you're disengaged. You've just disengaged from a debate. We can have a discussion. That's fine. So let's have a discussion. Go ahead. Do you,
well,
mhm,
I'm not convinced that I ever formally engaged a debate.
that's fine. It
So
honestly
I'm
doesn't
not disengaging from it. I'm
look.
just simply you asked me to look at some Python code,
Hmm.
and I'm glancing at it and uh, telling you that I do not have the expertise or training to know whether this code correctly models
Hmm.
what quantum functions.
Hmm. Okay, so are you stepping away from a discussion as well? I am not following. What do you want to ask me
It's not.
questions? Do you
It's not about me. I'm just saying that I'm just letting you know about
okay, let's
the
let
extent to which I can
I'd rather not have a meta discussion. Like, honestly, let's just have a discussion. If you want to ask me questions, if you want to say something, do like anything, just please not, let's not waste time. Like, please.
what is your objective in this discussion?
Quantum entanglement is utter nonsense. That's my proposition. Do you agree or disagree? Or do you want me to define quantum entanglement? Do you want to discuss it? I'm completely open-minded to, I'm open to any proposition, any counter proposition. Like, what's your position? Like, ask me questions, anything you want. So I put the final nail in the coffin of quantum entanglement today with this Python script. So we can go through this proof and you can try and falsify or invalidate my proof. That's why I'm here. I'm open. I want to be disproved. I'm looking to be falsified. I'm looking to be invalidated. At least my this this proposition. I want to harden the proposition and the proof. That's why I'm looking to debate it. I'm looking for you to find holes in my logic and the evidence. So, how would you like to proceed?
So what is your basis for why should I believe that you have falsified the bedrock of science for the last 100 years?
Oh, well, I don't know why you call it the bedrock of anything. I don't think it's even relevant, but I don't know why you call it that, but why do I think I falsified it? Well, um, so it starts with a video from Don Lincoln from yesterday, a debate that I had with Weasel, with Tapioca Weasel. Were you witness to that debate?
No, but I talked to him later,
Mm-hmm.
um, and he mentioned that you all had been discussing something or debating or something.
Mm-hmm.
He seems like a nice guy,
He is a nice guy.
very knowledgeable, very
Yes.
very
Yes.
professional.
Yes. Yes. So I'm using the side chat. So this image that I just posted, you can look at it. So Don Lincoln, you can see the Fermilab logo at the bottom right corner. This is from a video from Fermilab / Department of Energy / European Space Agency / Hubble. So there's some big guns behind it.
Where is it?
It's in the side chat of this voice chat. It's the last,
I see the Google Colab quantum entanglement
the
measurement
last,
simulation
the last,
and
the last. The last thing in the side chat.
Okay, it says I'll magnify it. Hold on.
Mm-hmm.
Okay, particle 1 measured direction, particle 2
Mm-hmm.
particle measured direction, measurement direction,
Mhm.
particle 2.
Mm-hmm.
And there's a diagram from 0 to 360
Mhm.
degrees on the x-axis,
Mm-hmm.
y-axis percentage in that direction.
Mm-hmm.
Data is a plot that is a very nice sine wave.
Mm-hmm.
Maybe 180 degrees off, but
It's cool.
um,
Mhm.
and then hidden variables looks like a straight line from 0 to 100 at 180 and to
Mm-hmm.
back to 0.
Mm-hmm.
Quantum mechanics is a red line.
Mm-hmm.
I assume that's theory.
That's Bohr.
And that oh,
Quantum mechanics
Bohr.
is the Bohr position of spooky action at a distance. The two particles are communicating instantaneously across the visible universe. The blue is Einstein Schrödinger hidden variables position. There is no spooky action at a distance. It's hidden variables. It was hidden variables all along. Unquote. I can explain everything, but I'm just this is from a video from Dr. Don Lincoln, Fermi
So
Lab.
this looks like it's from a paper
It's
or
actually
publication.
I don't
Did,
know where it's from, but it's from the Fermi Lab YouTube channel from Dr. Don Lincoln.
okay. Do you want to link to that and we can watch it so I can catch up?
Sure. I can explain it to you, but sure, whatever you choose, your preference. 1 second. Um, so here is a paper that I wrote. It's probably linked, but this is the paper. I'll open it, and in the paper there is a link to the video. I'll open that. I'll take the link from that and post that as well. Why don't you play and share it? Because I can't. Mm-hmm.
It's dramatic.
From time to
Yeah.
time, I give public lectures, and my very
Can you raise the
favorite
volume?
part is the question and answer session that inevitably follows. The audience often comes up with
You can
interesting
switch to
questions,
2x speed
but
if
one
you
of them
want.
sticks out in my mind. A young woman once asked me, "What is the weirdest physics phenomena that you've ever learned about?" Now, I don't remember how I answered her, but it got me to thinking, and I realized that I should have told her about a thing called quantum entanglement. It still blows my mind.
It's not
Let's see if you agree
2x.
with me.
You want to switch to 2x? Because he speaks
Broadly
really
speaking,
slowly.
quantum mechanics is a physics theory that describes the behavior
This is
of
pretty
atoms
dense
in the
stuff. I
universe.
don't know that I can learn quantum
But
mechanics
quantum
at
entanglement
2x.
allows
Oh,
for
okay.
weird quantum behaviors to be seen on sizes as big as people or even larger. So just what is quantum entanglement? In an earlier video, I talked about how the behavior of a subatomic particle, like a photon or an electron, is described by what is called a wave function. Brushing over many details, the wave function governs the probability that you will find the particle in a particular configuration. Before you make a measurement, you can't know, even in principle, what configuration the particle is in. To give a concrete example of what I mean by the word configuration, let's use the direction of the spin of a particle. Now, there is a quantum weirdness in that when you measure the direction of the spin of a particle, you first have to pick a direction, and then the outcome will always be either in the direction you picked or exactly opposite. It can't be anywhere in between. So, if you picked a measurement direction to be horizontal, the measurement of the spin direction could be left or right. It couldn't be up or down, forward or back, or any direction except for right or left. On the other hand, if you decided to measure in the vertical direction, the only outcomes of your measurement would be up and down. Left and right would be forbidden. It's certainly counterintuitive, but it's just a weird fact of life in the quantum world. Now, prior to the measurement, the wave function might say that the spin axis of the particle could be in any direction. Indeed, the most popular understanding of quantum mechanics says that the spin direction actually is in all directions allowed by the wave function. It's only when you make a measurement that the wave function collapses and the outcome becomes real. If you'd like some more information on wave functions and how they collapse, that other video might help. Now, what would happen if you had two subatomic particles? If you're like me, you'd think that they'd both be governed by an individual probabilistic wave function, and they'd be totally independent, with the spin direction of one particle having nothing to do with the spin direction of the other, and both of them being in all directions until a measurement is made. And that happens with four possible outcomes: two wave functions and two probabilities with all combinations of up and down. However, it's possible to prepare two subatomic particles so they both are described by a single wave function. That's what we mean by entangled: two particles and a single wave function. You do this by taking a parent particle, which in our example has zero spin, and let it decay into two particles. Spin is a conserved quantity, which means that it can never change. So if the parent particle has zero spin, then the two daughter particles have to have opposite spin. If one has a spin pointing left, the other is right. If one is up, the other is down, and so on. When you add the two, you get the zero that you started with. So that's the simplest example of a pair of entangled particles, which is to say two particles with opposite spin and a single wave function that governs both of them. Okay, so now we're getting somewhere. The entanglement doesn't depend on the two particles being close to one another. As long as the two particles don't interact with anything, you can separate them by feet, miles, or even huge distances, and the two particles are connected by a single wave function, and the two particles will have opposite spin. Now, remember that one of the key facets of quantum mechanics is that the quantum world is intrinsically probabilistic. We can't know, even in principle, the outcome of a measurement before we make it. So, suppose we select one of the two particles and pick a direction to measure the spin. Say we pick horizontal. The measured spin will be either right or left, each 50% of the time. We could have selected the other particle to do the measurement with the same result, 50% right and 50% left. The real weirdness arises when we measure the spin direction of both of the entangled particles. Say we measure the horizontal spin direction of this particle over here on the left, and the measurement says it's to the right. Then we know that the outcome of the other measurement, it will be 100% of the time left, 100% of the time.
I
That
didn't
means
understand that
information
part.
that one of the two particles had a measurement made on it was transported to the other particle.
Then let's stop it and discuss it.
100% of the time.
Okay. So
Okay, spin direction of both the entangled. So did he say spin is conserved?
yeah, spin is
So the-
conserved. That's good for
Okay, so the two measured spins have to add up to 180 or 100 or 360 or something.
no, to zero. The parent particle had zero spin. So it decayed into two daughter particles that have to add up to zero.
Gotcha.
hmm
Gotcha. Yeah. Okay. I understand that constraint now.
hmm
So now the jump
Mhm.
is
Jump.
observing the two different spins.
hmm
How do you justify the claim that observing one determines the spin of the other? AC line.
AC line. So
Mr. Slave is overturning quantum mechanics here
Oh God.
and quantum entanglement. Sorry,
Mhm.
but I've admitted I don't understand it that deeply to begin with. So
and I'm
I'm learning.
open-minded to being proved incorrect, so it's fine. So if you measure one of the particles and it's to the right, that doesn't mean the particle is to the right. Your
What does it mean
measurement,
then?
it means that it's actually in the right hemisphere of it's pointing at the right hemisphere of the universe. Because it could be up but your measurement 50% of the time would be to the right. That's just the way it works. So,
Okay, so
mhm. And by the way,
the,
what he says that it's weird, there's nothing weird about it. I mean, this is completely mechanical. We can have the exact same discussion about any classical object as long as it's in the dark. If we're in the dark and we can't see the object spinning, then we don't know in which way it's spinning. And we would have to arbitrarily pick a direction in which to measure it, and we would get an answer yes or no. But forget it. It doesn't matter. Everything he says is
yeah.
incorrect, but it doesn't matter. We can like it, the main
So everything this guy says is incorrect.
yeah, I mean, I just explained to you. There's nothing weird. When he says weird, he's wrong. But let's continue. I mean, not everything, obviously. I mean, he's my
Well, I
teacher.
mean,
He's my teacher.
Fermilab is pretty. We spend a lot of money to fund
He's my
Fermilab. Like,
teacher. He is my teacher. He is my teacher.
you know this guy?
He's my.
Does he know
He's
his teacher?
no, he doesn't
He's
know
your
me.
teacher?
He doesn't know me. But most of like a lot of what I know is from him. So I'm just saying, not everything, but a lot of stuff is incorrect. It doesn't matter. It's for our
Well, he must not be a very good teacher if you think everything he tells you is wrong.
no, he's a great teacher. He's the best there is. Let's continue. He knows by far more than
Well,
I do.
clearly he's not as good as you.
No. He knows, of course, he's my teacher, and I know nothing compared to him. But certain things I know more than him, and that's fine. Let's continue. So, do you have any
You said
questions?
everything that he
I
says
took it
is
back. I
wrong.
took it
But
back. I took it back. I took it
o-
back. Let's continue.
okay,
So,
okay, let's continue.
so
But
before,
tell me to stop when he's wrong. Okay, I
no.
don't want to hear
Hold,
wrong things.
no. Just to make sure you understand. So, if
The
we
rise. When we
measured,
measure the spin direction of
hold
both
on, wait. If we measure a particle to the right, does that mean the particle points at the right?
I think it's statistical, isn't it? Sea lion?
He's not listening. So as far
Oh,
as I know, this is also true for a classical object. So right, if you're and that's and that's what I've learned in quantum mechanics. So if a particle is
I'm trying
pointing,
to think of a time when you measure a classical object with its spin and measuring it to the right doesn't mean that it's really to the right.
but if so the way they measure it, when they say measure, they put it through a Stern-Gerlach magnetic field, and it either goes up or down relative to the magnetic field of the Stern-Gerlach apparatus.
A Stern-Gerlach
Yeah,
apparatus.
Stern-Gerlach.
Yeah,
So,
that's sounds. I thought that was a particular experiment that proved the quantization of spin. But he hasn't mentioned a magnetic field here.
but it doesn't matter. He doesn't discuss the details of the experiment. All he's saying is somehow we measured the direction of the spin. So I'm just asking you if the result is
Okay.
if the result is that the result of the measurement is to the right, what does that tell you about the direction of the spin of the particle? Where is it pointing?
Uh, I would guess to the right.
No. The
Well,
answer
then
is
your measurement tool is broken.
no. The answer is it's the right hemisphere of the universe. If the particle is pointing anywhere in the right hemisphere of the universe, then the result of the measurement is to the right.
Universe is a hemisphere.
I mean, if you divide the universe into two hemispheres, right? You can divide the universe into two hemispheres, right? Two halves.
Along what plane?
Well, if you're saying that the result is to the right, then slice the universe with a vertical plane, and you'd have a right half, a right hemisphere, and a left hemisphere. So if the
Okay,
particle,
so the path of the particle would lie in this plane,
not the path,
and it would be
not
oriented
the
at a
path,
right angle to your
not the path,
detector.
not the path. It's the direction of the spin. You know, we
That's what you're measuring.
but there's no path. There's no path here. There is a direction of the spin. The spin is an arrow that is pointing somewhere. We're
So we
deno-
have a
hmm hmm What?
so is it defined by the way we orient our detector?
I mean, y- if you remember the Stern Gerlach apparatus, so the magnetic field is pointing in some direction, and you throw
Yeah,
in.
but it was also non-uniform.
Yes, that's the way. That's the only way I know how to measure spin. So let's assume that's what he means. I don't. He doesn't go into the details. He doesn't tell us about how it's measured, and I don't know, and I don't think it's important. I mean, he doesn't tell us. I don't think it's important if I don't know what else to tell you. So I can make sense of
Are-
everything he says and explain it.
Is it okay if we just assume that Fermilab has a device for measuring spin that will,
Sure.
if it returns, if
Yes.
we orient it to detect spin to the right and it reads spin to the right, then that indicates that the spin is within a 180-degree range that we're just arbitrarily assigning right?
It's but the universe is three-dimensional, so you can't say 180 degrees. You have to say half. You have to talk about a hemisphere. It can point anywhere towards the right hemisphere of the universe. You could say
But you
180.
said Stern Gerlach, and that was a beam. That was a particle beam.
Yeah, but the the silver atom can point anywhere in spherical coordinates, but the particles only
Oh,
went up and down.
it was registering on a photographic film, which is two-dimensional.
Yeah, but the particle itself, the silver atom, could point arbitrarily anywhere in spherical coordinates, right?
Yeah,
So you can't
uh,
say 180.
maybe. I guess. I don't know.
Yeah, I mean, as far as I understand, of course. I mean, of
It
course,
depends on. I imagine it depends on how you generate the beam.
it's a furnace. It's a furnace. It's a vacuum. Right? In a vacuum, you have a
With an ion accelerator.
I actually missed your presentation, Mr. Slave. Could you repeat it for us?
no. You can watch the videos. We're moving forward. Um, so you have a vacuum chamber, and you have some silver, and you have a furnace. You heat up the silver, and you get silver atoms, I guess, by diffusion, leaving the furnace and moving along the magnetic field and impacting on the detector. But these silver atoms are not prepared in any way. They could be pointing in any direction arbitrarily in spherical coordinates. It's not critical. It's honestly, it's not important. If you want to only imagine a flat universe, that's fine. It doesn't impact the discussion. I'm being pedantic. It doesn't matter if you don't want to. If you don't want to think in three dimensions, you want to think in two dimensions. As long as you understand Don Lincoln, I'm fine because I'm just going to invalidate his. I'm going to invalidate his proof. So it doesn't matter.
Okay. All right. Well, let's back up and I'll play it again.
Sure.
Other particle to do the measurement with the same result, 50% right and 50% left. The real weirdness arises when we measure the spin direction of both of the entangled particles. Say we measure the horizontal spin direction of this particle over here on the left, and the measurement says it's to the right. Then we know that the outcome of the other measurement, it will be 100% of the time left, 100% of the time.
Do you understand
That
why?
means that the information that one of the two particles had a measurement made of
Conservation of spin.
No, but do you understand why 100% of the time, if one is left, the other one will measure to the right?
Entanglement.
No.
No?
Why do you
I
need
mean, has he
entanglement?
told us why?
He's going to. I mean, what? Wait, what? You just said conservation of angular momentum. Why do you need to say entanglement?
Well, you said no, and they're, related concepts in this context, I think, right?
I mean, but no, no, no. But I mean, f like entanglement means spooky action at a distance, so we're not there yet. But I mean, fine if you want to say that it's because of the opposite spin. That's fine. That fine. As long as you understand it, as long as you understand it so far mechanically. At this point, you should have a mechanical understanding of what's going on. There's no right. I mean, this is we could simulate this with a mechanical contraption in classical scale. Right. There's nothing special about this experiment so far. Do you agree? There's
I don't
nothing.
know.
I mean,
I
there's.
think that
Go ahead. Go ahead.
in classical mechanics,
Hmm.
if you had, let's say you had a top, a spinning top
In the
that
dark.
was
In the dark. We right because we don't want to be able to
sure,
see it, so we can't
yes,
see it.
with
And let's say the
blind people, no
and
one's around.
but
It's
let's
in a
say
sealed box,
but the only
the
way you
bottom of the ocean,
the only
and
way
all we have.
but the only
All
way
right. So are you gonna let me talk and like explain my understanding? Because you just asked me a question, right?
sure, I'm sorry. Go ahead.
Okay. So I think in a classical system, if you had a object with spinning angular momentum and you had a detector that could detect probabilistically, what hemisphere the angular momentum was pointing in, and the object split in half and went to two different detectors. The first detector would read probabilistically, and the second detector would read probabilistically. But what he just told us is the second detector 100% of the time reads different from the first detector. And that sounds non classical to me. That sounds like quantum entanglement spooky action at a distance.
But right, if but because of conservation of angular momentum, they're spinning in they're spinning exactly in opposite directions. That we can be sure of. If we assume conservation of angular momentum, then we're certain with mathematical certainty, we're certain that the objects are definitely spinning in opposite directions. So if one of them, if the apparatus measures in different directions, of course it's going to be 100% of the time. No?
No, what if the spin is right along the plane which divides the hemispheres of our
I
detectors?
agree. I agree.
Then that it's a 50-50 coin toss
I agree, but
of the first
I agree.
detector,
I
but
agree.
he is claiming that 100% of the time, the second detector will read the opposite of the first detector.
I agree. I agree. But let's ignore that edge case. I agree.
That sounds pretty fundamental,
No, I
isn't
thought
it?
so. I
Isn't that
thought
the
so.
essence of this whole thing?
No, it got nothing to do with it. I thought so. I thought this is relevant. It blew me. I was thinking about it, but you have to think about it realistically. There's no such thing as exactly that case. That case basically in right because of infinitesimally, it actually never happens. For all intents and purposes, it doesn't happen. You run this experiment a trillion times, it will never happen. There is no such case. That's what I'm assuming.
But I
Let's
look at
assume.
quantum
Let's.
effects, and they're
Mhm.
all very fuzzy. They're probabilistic, like
No,
position clouds, and
no,
this is a probabilistic function of angular momentum.
no.
There's not a perfect hard sharp cutoff line in the first detection, and the detector itself, it can't be perfect either.
No, I mean, I don't. So if we try and simulate, let me think through this. Um, it really doesn't matter. I mean, we can skip this discussion about the fuzziness because that's not what entanglement is about. Entanglement is about, does particle A communicate to particle B? Do we need particle A to communicate with particle B instantaneously? Do we need it? That's the only question. And my proof is we don't need it. I have a legit proof. We don't need the spooky action at a distance. Einstein was correct. I have proof Einstein was correct. All we need is hidden variables. And I actually have proof. Finally, there's proof. So
functions and how they collapse. That other video might help. Now, what would happen if you had two subatomic particles? If you're like me,
is
you
the
would think
volume on
that
max?
they'd both be governed by an individual probabilistic wave
Yeah, is it too low?
and they'd be
Yeah, it's too
totally
low. Did you
independent,
lower
with the
it?
spin direction of one particle having nothing to do with the spin direction of the other, and both of them being in all directions until a measurement is made. And that happens with four
That's
possible
good.
outcomes: two wave functions and two probabilities with all combinations of up and down. However, it's possible to prepare two subatomic particles so they both are described by a single wave function. That's what we mean by entangled: two particles and a single wave function. You do this by taking a parent particle, which in our example has zero spin, and let it decay into two particles. Spin is a conserved quantity, which means that it can never change. So if the parent particle has zero spin, then the two daughter particles have to have opposite spin. If one has a spin pointing left, the other is right. If one is up, the other is down, and so on. When you add the two, you get the zero that you started with. So that's the simplest example of a pair of entangled particles, which is to say two particles with opposite spin and a single wave function that governs both of them. Okay, so now we're getting somewhere. The entanglement doesn't depend on the two particles being close to one another. As long as the two particles don't interact with anything, you can separate them by feet, miles, or even huge distances, and the two particles are connected by a single wave function, and the two particles will have opposite spin. Now, remember that one of the key facets of quantum mechanics is that the quantum world is intrinsically probabilistic. We can't know, even in principle, the outcome of a measurement before we make it. So, suppose we select one of the two particles and pick a direction to measure the spin. Say we pick horizontal. The measured spin will be either right or left, each 50% of the time. We could have selected the other particle to do the measurement with the same result, 50% right and 50% left. The real weirdness arises when we measure the spin direction of both of the entangled particles. Say we measure the horizontal spin direction of this particle over here on the left, and the measurement says it's to the right. Then we know that the outcome of the other measurement, it will be 100% of the time left, 100% of the time. That means that the information that one of the two particles had a measurement made on it was transported to the other particle. And here's the spooky thing. We can measure the spin direction of the two particles in quick succession, so quickly that we measure the second one before any conceivable information from the first measurement could have arrived. Let's be super concrete on this by remembering that the fastest thing in the universe is light. It travels a foot in a billionth of a second. Now, let's take two entangled particles and separate them by 10 feet. It will take light 10 billionths of a second to travel from one to the other. So now let's get tricky. We'll measure the horizontal spin of one of the two particles and see that it's to the right. Then, 5 billionths of a second later, we measure the horizontal spin of the other particle. We find 100% of the time that it's to the left. And remember that we did it so fast that not even light could have told the second particle the outcome of the measurement of the first particle. That means that quantum information can travel faster than light. Yeah, you heard me right, faster than light. That blew Einstein's mind, too. In fact, he co-authored a paper in 1935 with Boris Podolsky and Nathan Rosen that highlighted this problem. He also called this transfer of quantum information spooky action at a distance. This was one of many reasons why Einstein didn't like quantum mechanics. So what do we think about this phenomenon today? Does quantum information move at speeds faster than light? Yeah, it seems to. But it doesn't invalidate Einstein's theory of relativity because we can't control it.
Okay, I don't think he's uh, explained this fully. I don't think he's given us a reason why this requires information transfer faster than the particles were leaving.
Let's
He's.
think about it.
I don't.
Let's think about it. So
No, I think we
mhm.
can't. I can't think about it because I feel like I don't have all the information here. Like he mentioned another video.
No, the other video you don't need it. It's like you can watch it. I mean, it's a short video, but I don't think you need it. But let's think about it because he might be right. I mean, there might be an issue. I might have completely been blindsided by this. So let's say a particle the particle A is pointing. So let's look at the clock. So we have 12 o'clock, 9 p.m., 9 o'clock, 3 o'clock, 6 o'clock. So let's say the particle A is pointing at 10 o'clock, but we're measuring it at 9 o'clock. Are we going to get 100% of the time true, left, or no? I think the answer is no. We don't get 100% of the time. This is a problem. Are you following what I'm saying?
Sort of. Like you said, it's left. It's not 100% right. Like you're
I mean,
saying that he's lying.
no. I'm not saying he's lying. I'm saying there is a problem that I didn't notice. This is a major problem. So if particle A is pointing at 10 o'clock, right? I'm looking forward and I have a clock in front of me. So a particle is pointing at 10 o'clock. So far, so good?
Sure.
Okay. But I'm measuring it, the apparatus is pointing at 9 o'clock. So what percent of the time will I get up, right? Up means with the apparatus. Right? I'm not going to get 100% of the time. It's going to be less than 100%. Right? I mean, that's the definition. I mean, this is the given.
It's not a given. He said that it works this way.
Yeah, I'm using it as a
He's given it.
given. I'm saying that like that's the given of that's what's given. Given that if the particle, right, the particle, we're going to get 50% of the time results to the right and 50% of the time results to the left. This mean and the particle could be pointing,
Okay.
but the particle could be pointing in arbitrary direction. So this implies that, I mean, logic dictates that if the particle is pointing at 9 p.m. at 9 and I'm measuring at 9, okay, then 100% of the time I'm going to get up, meaning with the direction of the measurement. But if there's a mismatch and the particle is pointing at 10 while the apparatus is still at 9, then I'm not going to get 100% of the time up. That's given.
I think so. Yeah.
Right, that's given. Now let's look at particle B. Now particle B, so we assume that particle A is pointing at 10, therefore particle B is pointing at 4. Right? Are you following my clock analogy?
Sure.
So particle B is pointing at 4. We know it. No, but right, only we know it because we're God. So we know that the particle is actually pointing at 4 p.m. But statistically speaking, we shouldn't be getting 100% of the time, right? And we're doing the test apparatus is pointing at 3 p.m. So we shouldn't be getting 100% up.
Right. It's a cosine
It's cosine.
probability.
It's actually cosine squared, but so the fact that so this is a problem. If it's true that we always get opposite detections, then I don't know the answer. Then I retract everything.
I
And
think that's what he's saying.
yes, that is what he's
I
saying.
think that's
Yeah.
I think that's just what bothered 20th century physicists so much about this phenomena.
Yeah, that I cannot resolve. That I don't have a resolution for. But that's not what this video is about. That's not what this video is about.
This video is about quantum entanglement, spooky action at a distance.
Yeah. You see, we're just halfway through this video. That's not what it's about.
We can make both measurements and the outcome will seem random, and we'll only know that the two were opposite when we compare the measurements, and that information can be transferred no faster than the speed of light. So that saves Einstein's theory, which is a relief. Otherwise, I'd have to learn a whole bunch of physics. But it's still perplexing. How is it that quantum mechanics can travel so fast? Well, there were some people, including Einstein, who thought that this wasn't so mysterious after all. Suppose that you had a red and a blue ball, but you couldn't look at them. You grab both of them and put them in boxes and separate the boxes. Later, you look in one of the boxes and see that it contains a blue ball. It will surprise nobody that the other ball is red. The answer was determined at the moment the balls were put in the boxes, not when the first ball was observed. And I admit, when I first heard about this, that was pretty much my reaction. The technical name for this more ordinary connection is called hidden variables. So the question is, how do we know that there is something new and different about quantum mechanics? How can we test the idea of quantum entanglement and compare it to the more intuitive idea of hidden variables? There's a long history of this, with a prediction in 1964 by theorist John Bell and a test in 1981 by Elaine Aspect, as well as contributions by many others. I'm going to forgo the history and the details of the mathematics of the predictions and just explain the measurement. We know that if we measure the spin direction of one particle, that the other one will be in the opposite direction. But let's change it up. Suppose that we measure the spin of the second particle in a totally different direction. How does that change things? Let's measure the direction of the first particle in the vertical direction, but the second one in the horizontal direction. That means that when you measure the spin of the second particle, it will be either right or left. That's weird, but remember, that's how this works for quantum spin measurements. Now, I'm going to simplify the discussion by only talking about the situation when the spin direction measured for the first particle is just up. We could be more general and include both up and down cases, but it's more confusing, and the answer is absolutely identical. If you want to do the general case, let me invoke the phrase that physics professors love and students hate, which is, the exercise is left to the student. Okay, now let's get into both the quantum and hidden variable predictions. The first measurement is in the vertical direction, and it finds the particle has spin up. When you measure the spin of the second, you measure it in the horizontal direction, and you get right and left with equal probability. The first measurement gives you zero predictive information about the second measurement. It turns out that both quantum mechanics and hidden variables make the same prediction for this scenario. This is very different from if you made the second measurement in the vertical direction, because if you did, you'd get a second measurement in the downward direction 100% of the time. Again, this is the same for both quantum mechanics and hidden variables. So now we're ready for the final bit, which is to look at all possible measurement directions for the second particle and see if the predictions are different for quantum mechanics and hidden variables. We will still assume that the spin direction measurement for the first particle is upward, and then measure the spin direction for the second particle, starting upward and then slowly spinning the measurement through 360 degrees. This graph shows the predictions of how often the second measurement will be in the direction the second arrow is pointing. If the second arrow is pointing upward, we know that the second measurement is always downward. So that means the second measurement agrees 0% of the time. If the second arrow is pointing at 90 degrees to the right, the second measurement can be right or left with equal probability. So it will be to the right only 50% of the time. If the second arrow is pointing downward, we know that the second measurement always is downward. So it is in that direction 100% of the time. And as we go to 360 degrees, the pattern is reversed. It's very important that we see that the predictions from hidden variables in quantum mechanics are different. This is key. So those are predictions. What does a measurement say? Well, these black dots show the measurement, and they are quite definitive. Quantum mechanics is correct, and the whole idea of hidden variables is completely ruled out. So what does this mean? It means that the idea that the final measurement is already determined that quantum mechanics is correct. And
Okay, so hidden variables means that it's determined in advance, and that's
Yes.
why you have a linear slope from 0 to 180 and back to down to 360.
Okay.
That
So Hmm. So I,
But
yeah,
the other one looks like a cosine.
cosine squared. So I wrote a program that's, follows his protocol, and I don't get straight lines. I get a cosine squared. I tell it to use cosine squared, so I get cosine squared. But there's no, I don't need any information from particle A to particle B in order to get the curve. I get the curve because I tell it cosine squared. There's no need for hidden variables. I mean, there's no need for spooky action for that. I mean, I don't understand. I mean, I don't even see the point. I mean, I mean, the whole issue is, how is it? But fine. I mean, my point is, I wrote the code that you saw, and there's a graph, there's a plot that follows. And the plot is curved because the code is cosine squared. Why would you say that hidden variables demand a straight line? I don't understand.
Because the two particles probability needs to add to 100, so you get a straight line.
What?
Whereas with this quantum mechanics stuff, it only adds to 100 at 0, 90, 180, 270.
Why would you say that? He never said that. Why would you say that?
Well, so you've got particle 1.
Mm-hmm.
So let's say measurement direction of particle 1 is 0.
Mm-hmm.
So particle 2 is what's being graphed.
Mm-hmm.
And if particle 1 measured 0, then it's reasonable that particle 2 would be measuring 180 with probability 100%,
No. But
right?
no, but that's because of entanglement.
In both systems.
But that's not because of probability. That's just the magic of entanglement. I mean, that already makes no sense. That already violates logic. That,
Okay, the y-axis says percentage in that direction. So I'm thinking that they had to
but it's not
do this
because
over thousands of
it doesn't
particles
matter.
and accumulate a percentage.
No, but
So it's
how?
a probabilistic measurement, right?
Yeah. But how can you have 100% and 0%? Like when you measure, so when you measured, right? So you tested particle one, and the measurement is up. That doesn't mean that the angle is up. That doesn't mean that the particle is pointing up. That means the particle is pointing towards the up hemisphere.
Okay,
So the particle 2
probably.
is pointing at the bottom hemisphere. But that means you shouldn't get 100%. You should get 50%. But they say no every time.
So I
Mhm.
think that it's not um a particle a hemisphere is determined. I think this is the relative angle direction between the two
Yeah.
detectors, right?
No, everything is relative. I mean,
But the x-axis, remember they talked about rotating the second detector
yeah.
in around 360 degrees
Sure,
relative to the first detector?
sure. I mean, I'm just saying. I mean, this to me is, if this is true, then I can't. I don't know. I don't have a solution for that. But for the curve, I used hidden variables and I got a curve. So I don't see the. I mean, if you look at my code, I used hidden variables. I used a single hidden variable, which is the actual angle, and I got a curve because I used cosine
Okay, but if
squared.
the variable were hidden, and it was transmitted along with the particle,
I I
then
I don't know what the variable is. I mean, it's hidden. The name of the variable is hidden angle. I never look at it. No one ever looks at it except for when the electron measures if it's up or down.
but the point is that the universe would know about it if this explanation were correct. The particles would know the value of this variable, even though it's hidden from the experimenter until the particles are observed.
No, look, there's two issues here. One issue is like this video. Don Lincoln has basically two parts to this video. The first part is that it's weird, and that is entanglement. That's the first part of the video, which he said it doesn't contradict Einstein because no information is traveling to us faster than light. We cannot use this to transfer information faster than light. We cannot violate faster than light. But the particles seem to,
Yeah.
but even if the particles seem to communicate faster than light, that's still because we cannot use this information faster than light. That means this doesn't violate Einstein's. That's what he said. But Einstein didn't like it.
Yeah.
I don't like it.
Sure.
I mean, in my universe, I can't. I mean, I can't have instant communication. That's
Yeah,
he.
but see, I think that you're right. There are two parts to this video, and it's really cramming a whole lot of, you know, counterintuitive stuff into 15 minutes.
No, I just think
And
the first part is counterintuitive. The second part, I don't understand. I mean, you might. I mean, I don't care about the second part. I don't understand why he even talks about it. The first part is the first
right,
part.
it's like a lot of flat Earth discussions. You're just better off if you leave Einstein out of it. It's not necessary to understand the interesting, proof or whatever. Like you have to first get your head around this graph
No, no, no,
before you can care
no,
about Einstein.
no, no, no. This
Like this
no, no. The first part is Einstein. The first part is how could it be that when particle A is detected up, then 100% of the time particle B will be detected down? That's impossible. That's
right, that has
impossible.
nothing to do with Einstein.
Fine, I don't
Hey,
care. I'm not.
hey,
Yeah.
hey, Marsh, I'm having a huge problem, and I really need your help.
Uh-oh. What's the matter?
Well, uh, can we talk about it over on your Discord?
I if you need to. We're kind of sure.
I mean, we're pretty much done. I mean, thank you, Marsh. I mean, you opened my eyes to the actual issue that I wasn't even aware of it. Now I see a
Well,
bigger
good.
issue. Yeah, yeah, yeah. I see a much bigger issue. So yeah, entanglement. I need to look into it. All right, Marsh. Thank you so much.
Hey, sorry to butt in. Apologize.
No, we're finished. It's okay. We've been here for a while. Thank you. Thank you. I'll see you later. Bye.
Yeah, thanks for sharing that with
Yeah,
me.
yeah,
I think I learned about
yeah. Me
this
too.
aspect today.
Yeah, me too. Thank you. See you later. Bye.
I'll see you later.
Yeah, thanks. Bye. Oh my God, this is devastating. I thought I had entanglement nailed up in a coffin, but now I don't. I actually don't. I don't have it nailed up. This was finally a good discussion. It's like it's so difficult to have a good discussion with people. So I don't even understand. Now I'm so confused. I don't understand. Now I'm hungry too. But now I'm confused. I thought I had it all cinched up. Now I'm so confused. Is this true? Is this true? Is this true? This makes no sense. If this is true, then I don't know what to say. What's going on with here? With this G oi oi. How do you know Liquid Zulu yo? I don't know Liquid Zulu. I don't know who that is. G. Mm-hmm. I don't know Liquid Zulu. You're a friend with him. I have many friends. I don't remember him. Let me look into DMs. 1 second. Okay, Liquid. I remember Liquid Zulu. Let me switch away. Switcheroo. So let's see. He's an objectivist and cap YouTuber. Liquid Zulu. Liquid Zulu. How do you search friends? There's no Zulu. There's no liquid. I don't see Liquid Zulu. I don't see him in friend search. Liquid Zulu. What is his actual name? Show me his profile. Friends. Nasashil is a friend? Wait, that's it? These are all my friends? I don't see Liquid Zulu. Oh, online. Okay, all. All right. Found him. Mm-hmm. Mm-hmm. Oh, okay. Found him. Okay. Yes, we talked. We talked in text chat. Let me see. Um. So I wrote all this, and he just disappeared. So I told him to join my server. It's okay, whatever. Are you an objectivist? I peeped your mom book in your server list on your team, on your stream. Yes, somewhat. Not totally, but very much. Hmm. So, okay. I don't have anything to say about entanglement then. Entanglement is too weird. Entanglement is too weird. I don't have an answer. I don't know what to tell you about entanglement. It's at this point I don't have an answer. I don't have an answer. I don't have an answer. So I was searching stuff about the Penrose theory of quantum consciousness and found your channel that way. LOL. Penrose is an idiot. Why don't you join my voice? Wait, how do you this one? Copy. So this is actually I don't have anything to say about entanglement. Don't have anything to say about it. What do you want? 1 second. Okay, good. Hey, Nicholas, what's up? If many angular momentum quanta lengths are elongated. Okay, Nick, I don't know what you're saying as always. I'm sorry. Who else had a comment? I think in the beginning, Nick, I'm sorry I had to threaten you with muting you today. I really wanted to talk to the other guy because it's like to you I talk all the time. So I really needed a private conversation. They update the top front software as well as combat attacks from foreign materials. What are we talking about here? I believe you would like Alcina Dimitrescu. Alcina Dimitrescu? Alcina Dimitrescu? Sounds like a woman. Alcina Dimitrescu? Alcina Dimitrescu. Yeah, definitely. That's Alcina. Yeah, I love her. She's amazing, definitely. Oh, look. She's doing dress up. Yeah, she's incredible. She's absolutely incredible. One of my favorites, definitely. What is wave can Oh, reply. There's a reply. Protons are tiny waves, they're not tiny balls. Photons. Wave containing balls that Einstein says, I think. No. I am telling you what I think. How dare you say what you think? How dare you? How dare you? Who do you think? Oh, Daisy. Easy leg workouts. She's very beautiful. She's really beautiful.
Yeah. So what is this second episode?
Left ear. How did you do the left ear?
Yeah, these are
Jesus.
just like some of the notes that I have to take before the workout session because I've only learned in Chinese, not in English. So
Did you have a Chinese trainer?
yeah, I used to have a lot of coach. Like I switched different coaches. Like they're famous. They are world. 8, 9, 10 reps each set.
Very nice. So the way I work. Wait, what was this? Okay, that's Alcina, and then you said that literally what I'm saying. They updated the top front softwares. I don't know what you're talking about. Okay. So the way I work is if I come across something, then I reply. And at this point, I don't have a reply to entanglement. I thought I did, but I don't. I don't have a reply right now to quantum entanglement. So that it is weird. If it's true, then it's weird. But the question is it true? If it's true, then it's weird. It doesn't mean, it means that temporarily I don't have an answer. Like about many things. I don't know many things about this universe. Mm, it doesn't mean anything. The fact that we don't understand, they used to not understand. Yeah, this guy destroyed his life. Unbelievable. How can you destroy your life like this? How can you do that? Really strange. And he was doing it for years. Anyway, it doesn't matter. Hmm. 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 Anyway, so. Hmm. What's up,
Oh,
Mr. G? Yeah.
yeah, can you hear me?
Yeah.
What's up, man?
Yeah, I'm fine. What's going on? So you're into quantum consciousness and nonsense?
You think it's nonsense?
Yeah.
Like the Penrose theory?
Yeah, he's an idiot. He's an idiot about everything. Nothing he says is of any value in every field.
I mean, I'm not equipped to like
Hmm.
discuss it or anything.
Hmm.
I just wanted to like, I guess I can ask you like what your channel's about, right?
Hmm.
You just debate physics on it, quantum
Uh,
physics stuff.
I do research. I mean, last couple of months have been research into physics. Yeah, but I debate anything. I'm open-minded to debating literally any topic. I have a.
Uh,
Hmm.
do you know who like Existence University is?
Yeah, he's an idiot.
Oh, I mean, you want to speak on that?
I mean,
Because I know he's pushing like Penrose a lot.
okay. Well, then you know what I think about Penrose. So, I mean, obviously, existence, universe, university, whatever. I think he's an objectivist. So
Yeah.
that's better than most humans by far. but that's still, relative to my stance, that's idiotic. He is somewhat idiotic. But I could say that about Yaron Brook too. Yaron Brook is also wrong about some essential stuff, and so was what's her name? What was her
Rand.
name? Yeah, Ayn Rand. She was.
You forgot her name.
Yeah, I
That's
forget
crazy.
names. Yeah. So.
But
Mhm.
like, did you have some sort of like spat with Existence University or
No,
something?
no, no. We just, like he was on my channel. Meaning he texted he wouldn't come online to debate me. He wouldn't visit my Discord to debate me. We endlessly debated in text, which is for me, I don't like it. I'd rather, it's much nicer for everyone, for me, for the other guy, and for the listeners. I mean, the last thing they want to do is read text. So he wouldn't debate
So
me.
like,
Hmm.
what was the disagreement?
I don't remember. Maybe about the ether, because
Oh yeah,
I believe in the ether. I'm like, Inductica.
yeah. I know Inductica.
Yeah, so he's also an objectivist, and
Mhm.
he believes in the ether, and he's like a physics philosophy professor or something. So me and
Right.
Inductica actually we communicate in email, and I showed him my papers. He said it's not exactly what he is doing, so we're not going to do anything. We're not going to collaborate for now. I think.
Yeah,
Hmm.
I know that Existence University and like Inductica they disagree a lot.
Yeah, it's fine. I mean, but when people don't debate, then they lose the debate. Like if you don't engage in a debate, then that's literally losing a debate. There's no
Oh
better.
yo, this guy,
Hmm.
this
This guy.
guy in your chat, he said he read one of my comments.
This guy
Hey,
in
which
my.
which one of my comments are you talking about?
You mean Nicholas? Nicholas Williams? Nick?
Yeah. Like,
Nick?
is he talking about me?
Yeah, sure. Yeah, Nick is a great guy. I like Nick, but 99% of what he says I don't understand. Meaning, as far as I'm concerned, it's nonsense. Yeah, maybe I'll discover one day that he's smarter than me, and he has the solutions to everything. But for now, I can't make any sense of what he's saying. By the way, you're breathing into your mic, so we can
Oh,
hear. Yeah,
am I?
we
Sorry,
can hear you like Darth Vader, basically.
I'm like on my Xbox right now
Yeah,
because
it's.
my
Hmm.
computer is fucked up right now.
I don't know what an Xbox is, so it doesn't matter. Like you might as
Bro,
well tell me. You might as well
are you
tell.
actually like Yaron Brook?
Am I actually Yaron Brook? No, I'm not actually. He's like South African.
Dude, like
Why
I
would
swear,
I
you
don't,
sound just like Yaron Brook.
but I don't agree with him on like we can go. I mean, he is obviously my source of information, my source of news, my only source of news, and I look forward to every episode that he has about anything.
I don't even watch Yaron, to be honest.
No, I love him. I love him very much, but he's wrong like everybody else about most things. But that's fine. Like what you.
So, I mean, you said you're almost an objectivist. So what does that mean?
I mean, for example, I don't agree with the term objectivist. The very name is terrible because I deny that we have access to objective knowledge definitionally. So the last thing I would call myself or anyone is an objectivist. I never use the word objective. I think it's the most improper word to use. It's the word with the least meaning in the universe, except for when you want to say that it doesn't that we have no access to something. Like the one thing we have no access, the one thing we have.
What do you mean definitional? Like,
The definition of objective is that we have no knowledge of it. That's the definition of objective. That's the
I mean,
definition.
I would say that's like a false standard, right?
What do you mean?
It's an impossible standard, so it's false.
I wouldn't say it's false. I would just say we have no access. By definition, we have no access to any objective knowledge. You're telling me that
Well,
something.
I mean, you know about
Mhm.
like Ayn Rand's trichotomy, right? Like
No,
the objective, the
no,
subjective,
no,
intrinsic trichotomy.
no. I don't know anything about her. I only know what Yaron Brook.
Well, like she makes the distinction, like,
Hmm.
well, she says that subjective and intrinsic, like what most people usually call objective
Hmm.
is intrinsic. That's
Hmm.
a false dichotomy, and her conception of objectivity is like completely different than what
I don't
most
care.
people like
I
use.
don't care. I don't care.
I mean, it's kind of like pretty important to objectivism.
I don't care about objectivism. I don't care. All I care is what I got from her. It's enough. I got enough from her to build my own philosophy. I don't need her anymore. I like her. She's better than most humans by far. She's one of the best of the best of the best. But I don't agree with her about everything. And it's not important. I have enough. I got enough from her that now I have my thing, and my thing is a little bit different. It's very similar but different. Like
And what is that?
I mean, I believe in economics. I believe in econometrics. I believe in mainstream economics.
I mean, I'm an Austrian, so like Zulu. So I kind of disagree with
What?
some objectivists on.
Okay, what do you
Well, I
dis?
guess most objectivists are Austrians, but like they're not really too explicit about it.
Like, well, I don't even know what it means to be an Austrian. How is being an Austrian
The
different?
Austrian school.
Yeah, how is I know, but how is being an Austrian different than being a mainstream a mainstream economist? What's the difference?
Um, like with mainstream economics, it's like a lot of mathematical economics. I
Yeah,
mean, Austrian is totally against mathematics and economics.
well, that's ridiculous. I mean, math is just a language. It's just like English is a language. Math is a language. It's just more concise. It's just more accurate. You're delivering your thoughts in a more crisp way and a way that is less ambiguous. Like English is, you can get ambiguities when you talk in English relative to when you talk in math. Math is just it's a better language for certain things. Like when you want to be precise, math has certain advantages. It's pros and cons, like everything else in the universe. To claim that there is only cons with something is obviously ludicrous. Nothing has only cons. That thing doesn't exist. I never heard of anything that is pure con. So I never heard
I
of
mean,
anything. I mean, if I wanted, it doesn't make any sense. I mean, I've learned, I studied economics, and the math part is it's critical. Like if I would have to use words instead of math, and that would be ridiculous. I mean, I use
I
vector.
mean that's like
Mhm.
a big part of Austrian economics. They're like
Okay,
verbal deduction
that's
from like
fine.
axioms,
That's fine, but
and like if you try to translate that kind of thing into like math, it just like it totally like loses its meaning
no, it
basically.
doesn't. No, it doesn't. It's called microeconomics, and if you study microeconomics, it's it's almost identical to the logic of the Austrian school. What do you call that logic?
Praxeology.
Yeah, praxeology is very similar to intro to microeconomics. Very similar. I don't even think there is a difference. There might not be a difference. I mean, if there is a difference, then praxeology loses because intro to micro is perfect. Intro to Microeconomics is, I would say, maybe the most
Intro to
beautiful.
Micro?
What did I say?
Is that a book or something?
No, it's Intro to Microeconomics. It's usually a course in university. It's the first year Intro to Micro. That's the first
Oh
thing you
yeah.
learn. That's the
I
first thing
mean,
you.
Rothbard has a lecture series or a course on that.
I don't need Rothbard. I mean, you go to any you pick up any Intro to Microeconomics book and you read it, and it's very similar to
Yeah, yeah, yeah.
praxeology.
It is definitely like
It's
they
it's
definitely adopt a lot of it for sure. Micro is pretty good, but macro is like it's like in the mainstream. It's just out there in the weeds
no
of like
macro.
Keynesianism.
Only one thing is more beautiful than Intro to Micro, and that is Intro to Macro. Both, I don't know which is more beautiful, but they are absolutely beautiful. Absolutely beautiful. Absolutely beautiful. It's unbelievable. I mean, just beyond belief. So to have any issues with micro and macroeconomics is
Well, I have issues that are like
what's your
with
issue?
economics that are not Austrian. That's my
Go
issue.
ahead. What's your issue? I'm not an Austrian. I'm a mainstream economist. What's your issue?
Well, that the method is wrong. The
Go,
Austrians have the correct method.
go ahead. I mean, that's nice title. Now
Well,
bring
yeah,
up.
I mean, I
Mhm.
have no idea like
What? So you just
what
made
you're even
wait. So
no,
you
I have no idea what you're even like
so
holding
what do you
here
mean what I'm
because
holding?
you just said like in general like introduction to micro and macro is beautiful.
Yeah.
I mean, I don't know what that means.
Okay, tell me one thing that you think is in Austrian philosophy, whatever, that I don't have. Like, tell me something that you think mainstream economics doesn't have.
um
Are you going to get high?
um am I gonna get high?
You know, I usually
Wait,
don't enjoy talking to people who are getting high. I need you focused.
okay, I'm focused.
Are you? But look, if you're gonna get high, then like I don't want to waste. Like I don't enjoy talking to people who are high, and then they tell me, "Oh, I'm sorry," and we ended up wasting time because we were talking in circles because they're losing their minds. I just don't enjoy it.
Okay, like I'm not really here for a debate,
We're
you
not.
know.
I'm not talking about a debate. I'm just saying I don't. I don't enjoy having any interaction with someone who's not completely functional. I just don't enjoy it. That's all. I mean, I have nothing against drugs. I'm the most pro drugs person in the universe. I just don't enjoy interacting with someone who is high because I enjoy intellectual discussions. I need 100% brain power, not less than that.
No, I mean I'm completely functional, bro. So,
But
but if you want me to,
are you getting high? Are we as we're talking right now? Are you trying to get high?
well, like I smoke, but like that's like often, so I'm not really high.
Okay, go ahead.
So are
So
we cool?
I don't look. It's I told you I enjoy talking to you because I enjoy your brain power. If you're going to reduce your brain
No, yeah.
power, then that's not. I don't enjoy that. I can talk to I can talk to anyone else who's a dysfunctional individual. I don't mean that you're dysfunctional. I mean like when you take drugs, you reduce your functionality. Anyway, let's continue. So if you become dysfunctional, we'll just we'll decide to continue some other time. So what do you think? What exactly is Austrian? Well, why do you think Austrians exist? I don't think Austrians exist. Tell me something. Tell me something Austrian. Tell me something Austrian. As an Austrian, tell me something that I wouldn't know as a mainstream economist.
Hmm. Let me think.
You have to think about it. So what? So you agree?
I mean, there's a lot.
No, there's nothing. If there's a lot, you would be able to come up with something right away.
So,
Yeah, go ahead.
like
Mm-hmm.
time preference, right? Are you
Time
familiar with
Are you
that?
out of your mind? Time preference? That's like intro to macro and intro to micro. That's of course we have time preference. What are you talking about? You think mainstream doesn't have time preference? We don't have interest rates?
I mean, I have no idea what you guys have
So of course
in
everybody
mainstream or whatever you're talking about.
you've never heard of interest rates? Never in your life you heard of interest
No,
rates?
yes,
Okay, then
in
that
Austrian theory, yeah.
what do you mean? You've never heard of interest rates outside of Austrian theory? Never in your life?
Well, I don't read like the other
You've
school
never
stuff, so
heard that when you went to third grade, they didn't teach you how to do interest rates? When you went,
no, they didn't teach me how to do interest rates in third grade.
they didn't teach. They didn't teach you compound interest in grade school or in middle school or in high school. You never learned about
No.
compound interest. Your parents didn't teach you. They didn't teach you to save your money in the bank and get interest so it grows compoundly. No one ever told you about this. The old, Mhm.
No.
You never heard that if you put your money in the bank, you get an interest on it?
I mean, yeah, obviously, but
What do you mean, obviously, but look, I'm getting upset now. Are you lying or are you being
I'm
truthful?
just like, I'm not really sure what you're asking me right now.
Okay, then you're high. Okay, it's useless. Your brain is not functioning. That's it.
I mean, you're asking me
I'm asking you a straightforward
about,
question. Tell me something Austrian. The best you got is time preference. Time preference is interest rate.
right.
Interest rate, everyone has interest rate. Every economic school has interest rates. Of course mainstream
Yeah,
of course mainstream has interest rates. So your Austrian, how great is Austrian
but I don't know.
school?
I'm not sure if they have like the Austrian theory, right? The time
Look,
preference theory of interest
I
rates.
asked you a
The pure
question.
time preference theory
Okay,
of interest.
I asked you, tell me something Austrian. You told me time preference. I told you time preference exists in mainstream. It's called time preference. It's identical. How could it be
Right.
different?
I mean, I don't know what they say about it in mainstream.
Okay,
I was
then
just like
again,
asking the question.
okay, again. You have nothing. Austrians don't exist. It's fake. It's fake. It doesn't exist. Stop pretending as if it exists. There's no such thing as Austrian. Nothing is Austrian. It's mainstream. Everything you have that's good is already ingested. It's already cannibalized by mainstream. Mainstream has everything that could be good. If it were good, it's already inside mainstream. So Austrians don't exist. You're welcome. Roll the credits.
Yeah, like I just have no idea what point to make because I don't know what mainstream
I
like
asked. It doesn't matter.
you're
You don't need to
referring
know.
to.
You don't need to know. But I told you. I asked you. Have you ever heard of interest rates? You kept denying as if you never heard of interest rates.
Well, no, I didn't. I wasn't taught about it in the third grade like you asked
Fine,
me.
third, fourth, fifth, sixth. You never heard of a bank that you put your money in the bank and it gives you interest rates. You kept denying and denying and denying until I got it out of you that you did hear of it outside of Austrian school. Yeah, you heard of it. So that's not Austrian. Everyone has it.
No, I didn't know anything about like
There's
interest
nothing
rates
to
or
know.
how they work.
But there's nothing. What do you mean how they work? What do you mean? You put your money in the bank and they give you interest on your money per time. That's time preference.
Yeah.
Okay, look. You don't exist. There is no Austrian school. There is no Austrian school. It doesn't exist. It's fake. Stop the nonsense. Stop pretending as if you exist. You don't exist.
Okay.
Unless, okay.
So what about the Austrian business cycle theory?
Okay. What is that?
Where
What's your evidence?
like artificial credit.
What's your evidence? What's your evidence that it exists?
What are you talking about?
What's your evidence? Present your evidence. I can also come up
For
with
what?
that it exists. It's a nice
That what
theory
exists?
that it exists. Do you have
Austrian business cycle
yes,
theory?
yes. Do you give me evidence? Show me the evidence that in the real universe, not in your mind, not in my mind, that in the real universe it exists. Show me. What's your evidence?
Bro, what are you
What's your evidence? Show me evidence.
what are you
What do you
asking
mean?
me
Wait,
right now?
you're not the only Austrian
Do you
person.
want me to like
No, you're not the
send you a
only.
link or something?
Sure, send me a link. Let's go through the evidence. What's your evidence that the Austrian business cycle exists? Sure, show me this. Show me. Sure.
I mean, Austrian business cycle theory.
Show me the
That's
evidence. Nice theory. Show me the evidence. Look, it's not. I mean,
evidence of what, bro? Are you asking me evidence if the theory exists? Like,
no
I'm not...
evidence that the theory is correct. What is okay? Explain to me the theory. What is the theory?
All right, hold up. I need to drink some water. My mouth is dry. So, like, essentially, it's you have like credit expansion, artificial credit expansion.
Explain that. Explain.
When banks like expand credit, they
Explain,
artificially lower interest.
Explain.
What do you mean explain, bro? What are you asking me to explain?
No, I'm fine. I'm following. No, it's fine. Maybe maybe it exists. If it does, maybe it's already been mapped into mainstream. Maybe it hasn't. Go ahead. Let's hear your opinion. What is the business, the Austrian business cycle? Let's hear it. Tell me the story
Right.
of the Austrian business cycle theory.
Now, do you want the history of it? Like,
No, tell me your story. Tell me the story. Right? A theory is a story. The Austrian business cycle theory is a story. Tell me the story. So one morning, a banker woke up and did what? Expanded the credit? What did he do? So I'm a banker. I wake up in the morning. I want to create I want to recreate, I want to reproduce the Austrian business cycle. So I'm a banker. You started by saying banks expand credit or something. So, okay, I'm a banker. I wake up in the morning. I want to create a business cycle. What do I do? What do I do?
so
Mm-hmm. What do I do?
to set like a business cycle in motion,
Yeah.
you'd have to increase the supply of credit,
Okay.
creating new loans.
Okay. Hold on. I'm a banker. What interest do I have to create anything? I'm a banker. I just want to make money. I want to give out loans and
Right.
and charge interest. And I want to.
Yeah. You're gonna lower the lending rates.
Why would I do
right?
that? Why would I change anything? I'm optimized as it is.
Well, this is like you're expanding credit
Why would I do
aggressively.
it? Why would I do it?
Right?
Why would I do it? Why would I do it?
Because you think that the state will help you when you fail, right?
Okay, but that's not going to happen one morning. I'm always optimized, right? I'm a banker. I'm a business. I'm always optimized. So whatever.
This is like why banks expand credit aggressively, right? It's because they think the state will bail them out.
Okay, let's assume it's true. So I wake up in the morning. Why would I do it today? Why would I not have done it yesterday?
Because like your friends in the government said that they're gonna bail you out if you like.
Fine. As soon as they said it, I should have done it. Why should there be a so? I mean, where? According to you,
it's like it's more. It's not just like a single bank thing. I mean, it could happen.
No.
But like isolated on its own.
No.
That bank would just like fail. Right?
Okay, so
it wouldn't
cause
a huge thing.
Exactly. So your theory is invalid.
No, I mean,
yeah, you just told me the
it's
theory.
macroeconomics.
No. You cannot set your business cycle in motion. It's fake. right?
Did you cut out there or something?
No, no, no. Before, right? In science, first we need to come up with a theory, then we go and test it. We can't even go to test your theory because it doesn't even. We don't even have a fully functioning theory.
You didn't, you didn't even let me get to the theory, bro.
I'm asking you how to set it in motion, and you said, well, the bank would fail. So I'm assuming you realized you cannot set your business cycle in motion. It doesn't exist.
Bro.
What?
You don't even let me get like a
I'm
sentence.
I'm not I'm not stopping you. You can interrupt anytime.
I mean, you did stop me.
Fine, then continue. We're stopping each other. This is not like there's no time. We're not playing chess. Go ahead.
I know. I just like I don't want to talk over you, bro. You know.
Feel free. Feel free to always
So,
talk over. Go ahead.
right. Set the business cycle in motion. You increase the supply of credit,
Okay, hold
creating
on,
new loans.
hold on. I'm a banker. I wake up in the morning. What do I do? And why? Why should I do something?
Bro.
Why should I change? What do you mean, bro?
So like, you reduce
Why would I do
like
it?
the reserve
Why would I
requirements
change?
because
Why would
if
I
you have that
change?
control,
Why? Sure.
or you're
Why would I
pushing
change?
for central bank
Why?
policies.
What are you talking about? What are you talking about? I'm a banker. I want to make money. What are you talking about? I'm a banker. I wake
Bro.
up in the morning. I want to sell money. I want to sell credit. What are you talking about? I wake up in the morning like every other morning before. Why should this morning be different than yesterday?
You don't even want me to explain it.
Just answer the question. Stop with the meta. Just answer the question. I'm asking you a
Like
question.
either you are a bank like that.
I'm a banker. I'm a banker. Given.
Yeah, right. Either you're a banker in like a free market and you don't have any control over central banks.
I'm a banker in the U.S.
Right.
I don't know what free market is. I'm a banker in the U.S. or whatever country.
Well, yeah. If you're a banker in the U.S., you're one of several, or like one of just a few, right? Of these corporations, right? That are
why should I do something?
in cahoots with the state?
Yeah, fine. Why should I do something?
They're all under the Federal Reserve. They're all under the Federal Reserve.
I'm not disagreeing. I'm not saying the banking system is perfect. It's far from perfect. On this, I agree with your own book.
Well, yeah.
The American banking system is way overregulated, a zillion times too overregulated. I agree with that. But that has nothing to do with the business cycle. Because
yeah, it does.
No, it doesn't. In order to get a cycle, stop laughing. In order to get a cycle, you need dynamics. The business is already optimized. Any business is optimized already yesterday. It's optimized. If I wake up this morning,
is it?
That's yeah.
I mean, like if it fails, then it's just gonna get. If it's gonna get bailed out,
hold on.
Like,
No.
according to natural market mechanisms, then
no, you cannot get a dynamic from that. It should have happened yesterday.
Exactly.
No, it should have. No, you a dynamic. If you don't get a dynamic, there's no cycle. You cannot get a cycle.
I don't know what you mean by dynamic.
Then what do you mean? What is a cycle? You need some sinusoid. You need a cycle. What do you mean? You're trying to predict a cycle.
What do you mean by dynamic?
Cycle. You said cycle, right? A business cycle. There's motion.
Yes.
Right? It's not static. There's motion. Why are you laughing?
Right, but what is that dynamic?
You said a business cycle. In order to get a business cycle, you need something to move. Why should I wake up today and do something? Hold on, wait a minute. No. Listen. Why should I wake up today and do something? Why didn't I do it yesterday? That's the question. And don't laugh. Stop with the laughing already. I'm tired of your laughter.
It's not like one banker just decides to artificially expand the credit.
Then you're.
It doesn't happen. These are central bank.
No. Then
policies.
you're. No. Then you. Okay. So you agree that if I am a banker and I wake up in the morning, I cannot produce. I don't have an incentive to produce. I don't produce the business cycle. Okay. We're done with the private banks. Okay. So let's start over. So you said in the beginning the banks, and now you're saying it's not the banks. So who is it? The central bank? The Fed?
It's the banks. Yes.
Banks?
They're
No,
all
no,
under
no,
the
no,
Fed.
no, no,
Right?
no, no, no. I gave you a chance.
Yes,
You
in
said
the
no,
US.
no. I
They're
gave
all
you
under the
no,
Fed.
no. I gave you a chance. You said it's not the private banks. So now we're left with the Fed.
It's not. Yeah.
Okay, so we're left
There
with the
is no.
Fed. So no, it's the
Right.
Fed. So only the Fed can create a business cycle according to you, right?
Well, all of these banks are.
I gave you a
inclusive
chance to defend
in the
your
US.
position that the private bank, you said the private bank, you took it back. So we're left with the Fed, the central bank. Then you said the central
No,
bank.
the private bank, right? The private bank in a free market. That's what that means.
No free
right?
market. We're in the United States. I don't know where the free market is. In the United States, or pick your favorite country. Let's have a discussion about this universe. Stop with the, I don't know what a free market is. There's a universe. We live in a universe. Talk about the universe, right? There's a business cycle in the universe. I claim there isn't. There cannot. Why do you keep laughing? Why do you keep laughing? What do you find so
Bro, I
funny?
just like I don't even understand what you're going on about, honestly, bro.
Okay, then ask questions. What do you find so funny?
So
why are you laughing all the time?
you
Why are
said
you
you said
giggling?
you're
Why are you giggling? What's wrong with you? Why are you giggling?
Bro, I mean,
No,
can we not have a conversation that's just like
no, you're like
cordial and
you're
cool?
treating me as if I'm saying something funny. That it's so obvious that I'm wrong. I keep destroying you. I keep mopping my floor with your face in this discussion, and like you keep laughing as if you're winning this debate. And I'm open-minded.
No, yeah, like you keep going, you keep going off in random directions, and not even letting me speak. So I don't know what debate we're having right now.
Okay. Look, I'm open-minded. Maybe there is a business cycle. Maybe there isn't. We can discuss it. But
Well, I mean, you said you're an economics student, right?
no, I didn't say
So-
anything. It doesn't matter what I am. It doesn't matter. Look,
Or you
it doesn't matter. It doesn't matter what I am.
have some
It
view
doesn't matter.
on
It doesn't matter.
on
It doesn't.
macroeconomics,
It doesn't
right?
matter. It doesn't matter. I don't want to have a discussion about me. That's boring. I want to have a discussion.
Well,
about...
I have to. I don't know what the hell you're
It
like.
doesn't
arguing
matter.
against,
It
bro.
doesn't
arguing
matter.
For.
I'm a regular person. I'm not arguing. I'm only. You're proposing. What's so funny? Why do you keep
You're
laughing?
saying, what do you mean you're not arguing? You're telling me the business cycle doesn't exist.
Look, I'm a regular guy from the street. You're coming to me and you're telling me that you have an Austrian business cycle theory. And I say, fine, present it to me. And you're telling me, okay, and I'm listening. And as I'm listening, it doesn't add up. Things are not adding up.
What are you listening
Why are you
to?
laughing?
I didn't even say a whole sentence.
Why do you keep laughing? Why do you keep laughing? Why do you keep giggling? What do you find so funny? Honestly, I don't understand. What do you find so funny in this discussion?
It's not like necessarily funny. I'm just.
So stop the giggling already. Like, be serious and have a conversation.
I can't enjoy myself when I have a conversation.
Like, you can mute yourself if you want to laugh. Like, when you talk to someone and you keep laughing.
When I have a conversation.
If you're talking to someone,
Sorry about that.
It's okay. When you're talking to someone and you keep laughing in their face, that's not nice. You might as well call me names. Like, I would ask you, why are you calling me names?
Well, I'm not meaning it like that. I'm just like. I'm trying to. I guess it's just a reaction to try and
you're
quell
pretending
the awkwardness that's happening right now.
Stop it. There's no awkwardness. I'm honestly trying to understand if there is or there isn't any validity to any claim that there is such a thing as the Austrian School of Economics. I'm questioning its existence. That's all. Maybe a few years ago, I used to define. Maybe a few years ago, I used to define myself as an Austrian too. But why are you laughing? What's wrong with you?
I don't know, bro. It's funny.
Why is it funny? What's funny? What's funny?
Because you're telling me the business cycle doesn't exist, that the Austrian school doesn't exist. That I mean, I don't even know what you're saying.
I'm not telling you. I'm not telling you. I'm saying Maybe a few years ago, I used to believe, I used to self-identify as an Austrian. Maybe. I no
Okay,
lo-
is that not evidence that the Austrian school exists?
no. If I mean, you could say that there's people who self-identify as Austrians. Sure, I
So I
mean,
mean, what does that mean that you self-identified as an
it
Austrian a
doesn't
few
mean
years ago?
anything. That's all it
It
is.
doesn't mean anything.
No, it doesn't mean anything. I can self-identify as a unicorn. There's people who self-identify as unicorns.
So
It doesn't mean anything
I don't.
except it
Then what are
doesn't
you
mean
telling
it
me
doesn't
when you
mean
say to me,
it doesn't
I
mean
identified as
it
an
doesn't
Austrian a
mean
couple of
it
years
doesn't.
ago?
You might as well identify as a unicorn. That doesn't mean anything except for that you identify. That's all it means, that you identify as a unicorn. That's the beginning, the middle, and the end of it. There's nothing more to it.
So like, why would you say it?
I'm trying to.
If you were just saying I identify as a unicorn, like what's the relevance of that?
I'm saying to identify as an Austrian has zero meaning beyond identifying as an Austrian. I don't
Then why
think.
did you bring it up?
What do you mean? You
Yeah, you said
claim.
a couple of years ago I identified as an Austrian. Is
No,
that like a
it's
lie
not.
or something?
It's not. I'm saying. I'm saying that I'm. But today I don't, because I used to think. I used to think that there is an Austrian business. There's an Austrian business school or an Austrian economic school. I don't think so any longer. I used to be like you, and now I'm not. And
So what
now
does that mean that you thought there was an Austrian school?
I would have. I would have. That's a good question. I don't think I thought too deeply into it, and I'm not even sure I used to define myself as Austrian, but I might have. But today, I don't think that there is an Austrian economic school anymore. I don't think it exists. Maybe it used to exist. Maybe in the
I
old.
mean, you can just look at the Mises Institute
Yeah,
at George
maybe
Mason University, right? There's like a lot of people that
that
study there
they
under
identify.
Austrian economics
Yeah,
there.
they identify as unicorns. I don't care. That doesn't mean anything. People can identify. That's fine. You can identify as anything you want. I
What do
don't
you
care.
mean? What do you mean by it doesn't mean anything?
If you identify as a unicorn, it doesn't mean anything. It has no meaning.
No, like when I say I'm an Austrian because I think the method of studying economics
I don't
is
think.
the correct method of studying economics is praxeology, right? Praxeology has all these axioms that you deduce the laws of economics from, and here are
I
the laws
told
of
you.
economics.
I told you
And
already.
the Austrian
I told you
school
already.
holds
I told you
this and
already.
this and this
I
and
told
this.
you. I told you. I told you. It's already been cannibalized by mainstream. If it's any good, it's already been cannibalized by the mainstream. So you have nothing. That's what I mean. Maybe in the old
Well,
days.
you still haven't told me what you mean by the mainstream. Like you just are generally referring to the mainstream.
So when you so I asked you, tell me something that the mainstream doesn't have, and you said time preference, and we've been through this, and we're done with that, and now you're moving to the business cycle. Like you're trying to claim that you have something that the mainstream doesn't have, and I claim either you have, and
Well, they definitely disagree with the Austrian business cycle theory. I mean, the Keynesians, right? The post-Keynesians.
I'm not talking about the Keynesians. Like when I say
I mean, that's the
mainstream.
mainstream.
Okay, if that's what you mean by mainstream, then you're right. But it's like not everybody's a Keynesian. I'm a mainstream. I'm not Keynesian.
I don't know what that means.
Okay,
I don't know what
then
mainstreamer
fine.
means.
Then okay, but look. Now you're bringing up Keynesian. Until now you didn't bring up Keynesian. Until now you were trying to push the business cycle theory, which I reject. I don't think it can exist. So we're done with. So we're done with time. We're done.
You don't think the business cycle theory can exist? Is that what you're saying?
Correct. Correct. We've been through this. I'm tired of that.
So
That's
there
like
is no business cycle theory.
we've been through this. We've been through
It's
this.
it's an illusion.
We've been through it. We're done with it.
No,
I gave you an hour. I gave you an hour. I gave you an hour. I gave you an hour to defend it. I gave you an hour to defend it. You kept pooping your pants. So we're done with it for now. We know I don't want to bore. I don't want to bore myself.
Okay, bro.
Like there's a limit to how much I want to bore myself in this discussion. So
are we having a discussion? I'm not even sure.
Anyway, look, I don't know what to tell you. So if you're not having a discussion, I'm not holding you. I'm not
I
trying.
was like trying to have a discussion.
If you feel that we're not having a discussion, then you're free to leave anytime. Like I'm, I think we're having a discussion. I think I'm mopping the floor with your face in this discussion. All you can do is poop your pants.
In what sense? Wait. In what sense?
Okay, so you tried to claim that there is a time preference in the Austrian school, and I showed you that it exists also in mainstream. So in that sense, you have nothing. And then
Yeah, but like the mainstream, right? I I don't know what you mean by mainstream again, because you said you're not talking about the Keynesians. Hello.
yeah, you
What
you
was
you
that?
don't like? No, I don't know. You keep laughing every time I talk. I thought maybe I would let you enjoy a little bit of your own medicine.
Okay.
Yeah. Now you're beginning to realize how I feel when I talk to you, right? It's not right? It's weird. You're not
Right.
enjoying it.
I'm like I'm trying not to laugh anymore.
That's good.
I'm
That's
sorry if it's like
that's a good thing.
offending you.
Look, you're talking to someone. Like imagine you were talking to a judge right now in a hearing.
Yeah, but I just met you, dude. And
It doesn't matter. It
I don't really
honestly,
know what you're all about. I'm
it
trying to
doesn't
figure it
matter.
out.
It doesn't matter. You can't behave this way. This is not proper behavior. Like and you're representing, objectivism, and you're representing Austrian, and you're
Am I?
representing the free market, and you're misbehaving in a way that is it is offensive. Right? You don't enjoy it when
I
I start laughing in your
apologize.
face. Okay, let's continue.
Um, what were we talking about?
So look again.
You keep referring to the mainstream, but like, I don't know what you mean by that because you said it's not
That's
the
fine.
post Keynesians or the Keynesians or
That's fine.
I
That's
don't know
fine.
what you're referring to there.
That's fine. That's fine. So yeah, I obviously Keynes is a fraud in my mind. I have nothing
Uh,
positive to say about Keynes. I don't view Keynes as mainstream, not in modern mainstream. So I don't care about. I was not taught about Keynes when I was studying economics in wherever I studied economics. So I don't care about Keynes. The only place I kept hearing about Keynes is from communists and Austrians. No one else discusses Keynes. It doesn't matter. I don't care about Keynes. So I studied mainstream
well, I
economics.
mean, a lot of
Mhm.
the policies, like central bank policies, the like whoever, I forget her name, Janet Yellen or whatever. She's a huge Keynesian.
Sure, I told
Like
you.
the whole.
I told you. I agree with Yaron Brook. Right? He invests in banks. That's all he does. That's his expertise. And I learned from him just how terrible the regulation around the financial system is and the banking system. So you don't have to convince me that it's a terrible system, but that's
Yeah,
given.
I just like I'm like
We don't
we
disagree on.
acknowledge that we are in like this Keynesian system, right? Where
I,
that's like
I
the mainstream.
I don't care. That has nothing to do with our discussion. If you if you think that when I say mainstream I mean Keynesian, then
I mean,
no.
I think that's relevant when you're asking me
I didn't
like a
know.
bank in the U.S.
I
right now,
I didn't know. No.
and
When I say mainstream, I mean main intro. When I studied intro to micro, intro to macro, that's mainstream. Those were books. They had nothing to do. They didn't bring up Keynes even once. They
yeah,
were.
I asked you
Mhm.
like if those are books or what you're referring to there, because I mean, even Rothbard has a course called Introduction to
It's
Microeconomics.
fine. It's fine. I'm just saying. Look, I used to only listen to Tom Woods and the other guy, the fat guy.
Hmm.
What's the other guy? The other guy. Who's his friend? That they had a podcast together.
Are you talking about Walter Block?
No, yeah, but I
No,
used to
not
listen.
not Walter Block.
Yeah, but I used to listen to the whole Tom Woods universe. I was completely immersed. I used to not miss.
I mean, I'm not big into Tom Woods.
It's
I
fine.
don't know
The,
too
the
much about
point
that
is
guy.
that he introduced to me uh, Austrian economics. I used to never skip a
Right.
show. And then, slowly I moved away from Tom Woods. I think that I actually, we actually had a little bit of a back and forth, and that's when I realized he's an idiot and a fraud and everything else. So, it's fine. So, and then, I moved on and I became somewhat of an objectivist, and that's basically where I'm at today. Somewhat objectivist, whatever. I call myself mainstream. I'm mainstream because I disagree with everyone, but I don't disagree with what with what I studied in mainstream.
Sorry, that was funny.
I don't disagree with anything that I studied in mainstream. Like intro to micro, intro to macro, there's literally nothing I disagree with what they taught me. And there's no Keynes, right? There's no Keynes, but it's not objectivist. Of course, there's a lot of math, and I love the math. I love the math. There's a lot of math, matrices and vectors and differentials and
Yeah.
partial differentials and
I
Lagrangian.
mean, you don't have any of that in.
Okay, there's nothing to be proud of not having mathematics. There's nothing to be proud of not having tools. Like the fact that you say I go to work without tools, that's nothing to be proud of.
Well, it depends what you're saying. Those tools are being used to, like economics as a science, right?
Yes.
It's supposed to tell you something about economics, right?
The economy.
And if these tools, if you're not, they're not telling you anything about economics, then they're useless.
Economics is a science that tells you about the economy. Economics is a science to study the natural phenomenon called the economy. To analyze the economy. To analyze the natural phenomenon known as the economy. That is economics.
Well, I think a better definition would be economics is the science of exchange.
No, economics is a science
because you have autistic exchange too, where there's an economy of a single man, right? Like Crusoe on his island alone. He's still economizing scarce resources. Right?
No.
Or is that not the case?
No,
he's not economizing
economics.
Scarce resources.
No. I said no many times.
Yeah, but why is Crusoe alone on an island not economizing scarce resources?
He is, and there's no exchange.
Right, he is. Yeah, no, he's exchanging
with whom?
He's exchanging
with whom?
Like one state of
with
affairs
whom?
for another, right?
Okay.
Well, no, this is how we discover the laws of like marginal utility and stuff, like isolated, just one guy,
I don't care.
economizing.
I don't care. The definition, my definition of
that's part of economics.
I don't care.
Autistic economics or Crusoe economics.
I don't care.
Is a huge part of economics.
I don't.
I mean, that's in mainstream too.
I don't care. So my definition.
You don't care about Crusoe economics?
I don't care about anything you said vis-a-vis the definition of economics. I'll repeat my definition of economics. My definition of economics is it's the science of studying the natural phenomenon known as the economy. That's it.
Well, then you're leaving out Crusoe economics.
No, I'm not. It's his economy. It's the Crusoe the Crusoe economy. That's the first chapter in Intro to Macro, the Crusoe economy.
Yeah, it's an economy of one man.
Yes, it's an economy. Yeah, it's an economy. It's an economy of one man. Yes, and we study that economy.
So, yeah, so you're just studying exchange.
No, it doesn't matter.
Yeah.
Okay, fine. You look. I don't care. This is just a definition. Who cares? This is not important. So you want to define economics however you want to define it, and I'll define it some other way. I don't care.
I just want to include Crusoe economics. That's why.
So I told you that's included but it doesn't impact my definition. And if you're happy with your definition, I'm happy with my definition, and we don't have.
No, that's cool. Yeah.
Yeah, it doesn't matter. I don't care. I don't care how you define economics, as long as we don't have. As long as I understand your definition, you understand my definition. It does
Hmm.
nothing else matters. We can have a discussion. Definitions are just tools to have a discussion. So I know how you define economics. You know how I define economics. We can proceed and have a discussion. Anyway, so with all due respect, I honestly don't see how the Austrian School of Economics exists, except for it self identifies as such. That's it. I don't have anything to add. So
I have like zero clue what you mean by that.
that's fine.
I mean, there's clearly an Austrian school. There are many unique contributions to the science of economics from the Austrian school.
Name one. You
And
tried naming. You tried naming.
I
Time
mean,
preference.
Bumble-work and
Wait.
his capital theory
I
and
don't.
like
No.
I mean,
no,
Menger,
no,
like
no,
marginal utility.
no. Look, I gave you chances. You said time preference. I showed
I mean,
you.
Menger was the first
I'm not
marginalist, right?
denying. I said maybe in the past there used to be an Austrian economic school, maybe, but there isn't today.
Well, there still is
Maybe
because
it's
it's.
maybe it still identifies as such, but I don't see the difference
I
between
mean, what makes it not an
I
Austrian
gave
school?
you a
Like,
chance. I gave you chances to show me how Austrians say anything
I mean,
different.
there's clearly a school called the Austrian school that's different from other schools of economics,
There's definitely
right?
people who identify as unicorns. That doesn't mean anything.
I mean, do you not think that Austrians are different from Keynesians
No,
or
no, I'm
Marxists?
not talking from Keynesians, sure, but not from
I
the
mean, there you go.
look. If
There's a
you
differentiation right there.
look, okay, fine.
Austrian school is
Yeah,
different
I don't
from this other school,
look.
so the school exists.
Okay, I think we're done. Have a great rest of your day. Anything else you want to add? 'Cause
Okay.
I'm tired of talking to you.
I mean, not really.
That's good.
So,
Because like next time, I'm definitely not talking to you while you're high. This is ridiculous. Absolutely wasted time.
okay, man. Have a good one.
You too. Bye. Don't come back ever.
Okay.
Wow. I always make the mistake of talking to people while they're high, and it's such a waste of time. It's that's exactly why I hate talking to them. They keep laughing and talking. It's even worse than talking to idiots, which is terrible too. Anyway, I think we're done. Are we done? I'm still perplexed by entanglement. That was perplexing. Yeah, you're the only one watching. Yeah, you're the only one. It's just me and you. Um. Oh my God. Okay, I need to look into. Um. mm, I need to have boundaries. Like when I hear them lighting up, I need to tell them like I don't like come back when you're not lighting up. What a waste of time. It's always a waste of time. Is Nicholas here? I don't, not with me. You're welcome to join me. As long as you're not high or drunk. If you're drunk or high, please stay away. I need to have like oh, check this out. New York Police Department officer busted selling fentanyl and heroin while on duty 3 days ago. Plus, she's hot. Young mom from 2 months executed in front of her two kids in disturbing road rage murder. Oh my god, he's shaking. Is he shaking? So he murdered her? Yeah, road rage is terrible. Like, there's so many reasons not to switch to autonomous driving, but our politicians are betters. They're not going to let us switch to autonomous driving. Why is the integral of 1 over x equal to the natural log of the absolute value of x? I turn heads. Psychotherapist with insatiable desire for X conspires to ill. Complex numbers. Wait, nobody can fix this New York skyscraper. My ex fiance sued me for $9 million. Wow. I love Hamas. All right. Eviction. She got super mayor. Oh, super mayor versus the people. The Pauli exclusion principle. Ethan's Ukrainian employee calls out Hassan. I don't know. I'm still perplexed about. Do you know his Discord? Let me find it. There it is, Nick. I think you go like this and you're. Oh, I can just do Nick? No? No? I guess not. I don't get it. It doesn't capture it. I don't know. But I'm not friends with him, or maybe he's not online. I don't know what's going on. I don't know how to give you Nick. I don't know. He's not in the server? Maybe he's not in the server. I don't know. I don't know. Anyway, come back if and only when you are not high, please. It was very distressing for me. Let me think. Okay, let's look at. Look at this guy. ChatGPT skeptical about neutrinos. Neutrino evidence revisited. AI debates. Interesting. So what I'm wondering about is it what's how do we know about entanglement? What is the evidence for entanglement? Entanglement. What's the evidence? Quantum entanglement demystified. Understanding quantum mechanics, superposition, and entanglement. What's the experiment? No, I'm done for tonight. No, not tonight. If ever you want to come back, then please not while you are high. Have you thought about debating Zulu? He invite him. How entanglement breaks the universe. What is the evidence? How to make entangled photons. Let's try this.
How do you actually produce entanglement? Hi guys, welcome to 20 Apple Drops. I'm Ben. So this week I want to do just a really quick video, just a follow-up to what we did last week. If you missed it, you can see it.
This is 9 years ago. Wow, 486K. So you want to debate Liquid Zulu. This time we will provide guidance on scheduling a debate with me. I don't like chasing people. You can invite him. He accepts debates with anyone who disagrees with him. I have DMs with him. He never responded to my last comment. He's not gonna join LOL, and I'm not gonna go out of my way. No problem. I am more interested in quantum mechanics these days. I'm tired of debating stuff that is super clear to me. You know how big his channel is though, right? He would definitely debate you on objective knowledge. I don't like I don't like chasing people. I have bad experience chasing. They test me. They see they will lose, so they play games, block me, and such. So if he shows up here, great. Else, not gonna go out of my way. Okay, let's see. This is interesting. So what's the actual evidence for entanglement?
Here, but we were basically talking about quantum entanglement. Now, quantum entanglement is the idea, just to remind you, that two particles can be linked in such a way that if you go to do something to one, if you go to take a measurement on one, will immediately affect any measurements you take on the other. And this is regardless of the distance these two particles are separated in space. And that is a really weird idea, but what's stranger is the idea that this is always presented to you as a given. Given that you'll have these two entangled particles. But how do you actually produce entanglement?
That's not important. Well, if you want to, you can, and I doubt he'd do that. If I want to do what? What are you talking about? It is really not important to me. My door is open.
That's what I'm interested in finding out today. How do you actually produce these entangled states? So what I've done is I've come to the Center for Quantum Photonics at the University of Bristol to talk to a man called Jack Caroline, who is trying to build a quantum computer using these entangled states. So it turns out there's a few different ways to produce entanglement, so we'll just be focusing on one. But let's go down to the lab and find out what Jack does and how he actually does it. So Jack, tell me a little bit about how you build your entangled photons.
So we want to get entangled photons, right? And the way we do that is via a process called spontaneous parametric down conversion. Okay, that sounds loads more complicated than it actually is. It's really simple. It's just a process whereby one photon splits into two. So I can show you how we do that over here. Right, because we get a big laser beam, we fire it at this crystal. So there's a special type of non-linear crystal. When you put light into non-linear materials, weird things happen. Okay, and in this particular one, two photons pop up. So what the important laws of physics? Right, well, there's conservation of energy and there's conservation of matter. So let's imagine this crystal is a non-linear crystal. I'm going to fire a photon in it, and it's got some frequency. Right, it's got some wave.
So I think I've seen this video before. And I couldn't really understand what's going on, but fine, let's try it again.
Tells you that's energy. Okay, so energy is an h bar over gas. And then two photons are going to pop up. Like I call number one and number two. And we know that energy falls will equal energy afterwards. So energy of these guys must add up to energy of this guy. So the frequency of these guys is half frequency of that one. Okay, so that tells you about the energy of this guy. So what the wavelength is going to be. So we pump it with 400 nanometers light, and photons that come off at 800 nanometers. Okay, so you tell me.
Okay, I don't understand his English. He has highs and lows. People sometimes don't speak in a constant amplitude. He changes the amplitude violently, so it's difficult to understand him at 2x. Let's try it 1x.
Energy force will equal energy afterwards. So the energy of these guys must add up to the energy of this guy.
1.5x.
So the frequency of these guys is half the frequency of that one. Okay, so that tells you about the energy of this guy. So it tells you what the wavelength is going to be. So we pump it with 400 nanometer light, and the photons that come off at 800 nanometers. Okay, so you send a beam of light into.
Okay, that makes sense. So it enters at 400 nanometer wavelength, and they come out each 800. The wavelength, if it grows, that means the energy is reduced, and it's apparently linear. So you enter at 400 to leave at 800. That's fine.
Into this nonlinear crystal, and each photon that comes in then produces two photons coming out of it. Not each one, some of them. There's a very small probability it's going to happen. But because we've got a big laser that's got trillions of photons in it, you can make that probability appreciable. So we see lots of photons. Conservation of momentum, right? That's also very important.
He's gay.
So if you look around here,
Jesus Christ.
Right, our input photon is moving that way. Okay, so what we don't want to have.
Okay, it's good that when you say it's moving that way, you're moving your finger back and forth so that we have no idea where is the emitter and where is the receiver. And everything is like, I don't know, is this the emitter? I don't know. I honestly don't know.
there's 2 photons coming off here. That's really bad. That's physics.
Okay, so that's the receiver. Okay.
Like that. That's actually why we've got 2 prisms bouncing right up here.
Oh, there's 2 prisms. Okay, so one photon will reach this, and I guess we'll hit this, and it will bounce to the right, and one will bounce to the left. Okay.
The photons come off like that.
So at this point, we've made our 2 photons by sending in this light into this crystal. Is this entanglement? Have we done it?
Not quite yet. It's not quite the useful entanglement that we need to do something like build a quantum computer, okay? Because to understand how you do that, you really need to know something a little bit more about this crystal, just a little bit. And the crystals care about polarization. Okay? They care about the way the light moves inside it, right? So if imagine I get a crystal. If I input horizontal light.
So, okay, I hope we're not going to get confused by too many topics, because I don't want to talk about polarization, but I guess polarization has to do with spin. So maybe he's trying to figure out spin or something.
H. The photons that come out are going to be vertically polarized. So this is one type of crystal. I'm going to call this number 1.
What does that mean? What does that mean? I don't know what that means. I don't know what that means. I don't know what it means to be vertically polarized. I'd like you to explain that, please. What does that mean? What is a photon? What does it mean for a photon to be polarized? What's vertical polarization? What's the process? What's going on?
What I can also do is rotate this guy by 90 degrees. Okay, just take the same one, rotate it by 90 degrees, such that if I input vertical light, okay, the photons that come off will be horizontally polarized. You get one of these and one of these, put them up next to each other, okay, crystal 1, crystal 2.
So you take 2 crystals, the 2 different crystals. So you enter horizontal, you get 2 verticals, whatever that means, and then you put them next to each other. So you take the vertical and you reconvert it to be 2 horizontals. So you're gonna have 1, 2. You're gonna have 2 times 2, 4. You're ending up with 4 photons.
And you input what we call diagonal light. Okay, diagonal is a mixture of horizontal and vertical.
Horizontal and vertical is diagonal. What a mess. Why are you making it so messy? I mean, in the illustrations, it's always so simple. Why is it such a mess? So it's a combination of horizontal and vertical, which is diagonal, which I don't even know what that is.
And if you get photons come out, you don't know whether they were created in the first crystal or the second crystal.
What? What does it mean to have horizontal plus vertical? So if, I mean, it's 2 separate photons. I mean, I don't know. We don't know. I don't know what we know. I don't know. There's too many. There's already so many variables. There's already so many moving parts. This is useless. I want to see entanglement like I was promised. I was promised that it's possible to create 2 particles with opposite spins, measure each one of them, and always get opposite spins. That's what I was promised. Why is it becoming so difficult to deliver on this promise?
So you've got to say it's either horizontal or vertical. Okay? And that is an entangled state.
I don't get it. I have no idea what's going on. Either both are horizontal or both are vertical. And that's entangled state. I don't know what that means. I have no idea what you're saying.
So my question is, why can I not just try harder and work out which crystal my photon was actually going through? Isn't there some measurement I can do that just tells me, and makes this just a question of uncertainty
Try and make it more shaky.
as opposed to a question of entanglement?
No, this is quantum physics, okay? This is quantum physics. We're dealing things with photons. Okay? Now, in this quantum regime, you have things that are superpositions, right? And this is a superposition. Imagine you've got a coin, okay? If I take a coin out of my pocket
Oh my God, again with the endless analogies.
and flip it, right? A coin in our classical macroscopic world. In principle, I could pause time in reality, and I could work out the momenta of every little bit of the coin, and I could work out the air currents that are moving around it, and I could definitely say whether it's going to be heads or tails. That's in principle possible to do.
No, you can't. You can't. You're asserting you can, I'm asserting you can't.
Really hard. But with a quantum coin, with a quantum superposition, you can't ever know.
There's no difference. You can't really know in the macroscopic world either.
It doesn't make sense to say whether it's going to be H or V, heads or tails. And that's the situation we've got here.
Okay, so that's no different.
So last week we saw abstractly what entanglement is. This week we tried to get a more practical idea of what it actually means.
And we got nothing. Zero. Absolutely zero.
Create this entangled state. We did this because I wanted to debunk some of that idea that entanglement or quantum things in general are spooky, because they're not. What quantum mechanics comes down to is that there is some physical process which is occurring, and you can't know what.
What do you mean? The spookiness is that whatever you measure particle 1, you're going to measure the other particle opposite, which is how? How do you get that? It's the flip of a coin for each. How do they end up always opposite? How? How is that possible?
What it is. Because as we saw last week, as soon as you go to try and take a measurement on it, it affects the system. It's no longer that same state. Now, when you've created two particles which
How?
come from a common source and both have this sort of quantum veil about them, you have to think of them as entangled. Now, what this means is that to understand
Show me the evidence.
what's happening to one of these photons, you need to consider the entire system. You need to consider both photons.
Show me the evidence. Stop with the nonsense. Show me the evidence.
Regardless of how far apart they are. Now, it's precisely because they are a single system that measurement on one will affect
What's the evidence?
the other. And people will call it weird because this idea of a space-separated system doesn't happen in classical mechanics. The quantum veil only exists.
What's the evidence? Show me the evidence.
In quantum mechanics. The idea that you can't see what's happening.
Show me the evidence. What you can't see what's happening also in a dark room. That's no different. That's not what makes. That's irrelevant.
So you must account for everything. Okay, guys. Well, I hope you enjoyed that. It was just a sort of slightly different look at quantum entanglement than
No, it was terrible. I did not enjoy that the least bit. You wasted my life.
I hope you were used to. If you like this sort of video, then do consider subscribing to the channel. The link is over there. And if you have any sort of feedback, then definitely leave it in the comment section below. I always read everything that's put there. I'm actually off to America for a few weeks, so I'm not entirely sure about what I'm going to do about putting up videos, but I will do my best. But anyway, most important thing, have a lovely week, and I will see you hopefully next week. Bye.
Yeah, waste of time. Complete waste of time. Show me evidence for quantum entanglement. I claim there's no evidence for quantum entanglement. 1 second. It's whatever is weird, I claim it doesn't exist. I'm asserting. Show me the evidence. Evidence for quantum entanglement. Is anyone on the Globe server? No.
Order polynomial, but I was kind of pushed into it.
Oh, Taylor busted him
Hey, what's up?
withholding the polynomial.
Yeah, it just seems strange because if you're using the same calculations.
Hey, can somebody talk?
Vastly different heights of,
Hello, Mr. Slave.
Hey, what's up? Can you talk, Marsh?
Yeah,
I
we're
can
watching
talk.
a live stream.
Yeah, I know. I have a short
Very
question.
good. I did get a different elevation at each setup, and it was
a uniform
Sure.
exponential drop.
Let's. I would go to another channel, but I'm the one streaming. How do
Yeah.
you do this?
I don't think you can.
Okay. Let me. I have another account.
You can
Hold on.
Oh, you can pause it. I mean, it's a short question. If you want to, the question is.
No, it's live and other people are watching.
I mean, 1,
which is
2,
13% larger
maybe 3, I guess.
than the 3960 miles radius of Earth.
I think I see this.
Okay, so let me know if you're gonna talk to me somehow.
Just give me a minute. Hold on.
Yeah, no, yeah, sure, I'm waiting.
How much, how many? Let's say you're doing a study on how many, what percentage of cells die petri dish with the
I mean, we
additional
can always.
bunch
Oh,
of
never mind.
soy cell poisoning,
I
and you do it
I'm
at
watching it off of the website.
Okay, I'm over on
You
Hot
can
Mic.
together all that
okay.
Hot mic.
Well,
and then
you
your
Got
size that
it.
you use would
Hey, what's up? Can you hear me?
Yeah, what's up?
Hey, so I was thinking, it doesn't make any sense. So, what's the evidence we have for what Don Lincoln presented? Like, how do we know this actually happens? That when you measure one particle, you always get the opposite measurement for the other? What's the evidence?
It it's like a century or more of physics experiments.
Sure, but can I see it? Can I see it? I mean, if it's a century, then I should be able to see so many examples. But when I look for an example on YouTube, there's zero. There's literally zero. There's just animations, 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 endless animations, and analogies and animations and analogies. Not a single experiment. So if it's been a century, I'm sure there's plenty of evidence. So why is there none on YouTube? I want to watch it.
Um, I think that the experiment is old and not very interesting.
It's what do you mean?
And so
I
it wait, hold on.
yeah, okay.
I think it's a combination of factors.
Mhm.
Let me just list them in no particular order.
Mhm.
Um, it's an old experiment, over 100 years old.
Mhm. Mhm.
It it involves particles, so it requires a lot of specialized equipment,
Mhm.
like high vacuums, precision detectors,
Mhm.
specific kinds of particle sources.
Mhm.
It's so it's going to require like a university lab at least.
Sure.
It um it you don't see any interesting results. Like it doesn't glow on a phosphor. It doesn't make children laugh. It's not a good demo. Like all you get at the end of it
Mhm.
is a bunch of data and
Mhm.
numbers in a computer, and then you have to do the correlation of the numbers in the computer
Fine.
to see the effect. And so these factors, I think they combine to be just not good YouTube material. I could be wrong,
It's
but
I claim it
I
doesn't.
have to think it's been replicated
It's
many
fine.
times.
Look, I claim it never happened. You know me. Like, show me the evidence until and I'm open-minded. You saw how I'm open-minded. As soon as there was an issue, I retracted everything and I withdrew and I thought about it and now I'm back. So, as far as I'm concerned, it doesn't exist until the evidence is presented and I can scrutinize it. I'm I'm
Okay.
I'm not like I'm not like upset or I'm not saying it's a government conspiracy. That's not that's not my
So do
go-to.
you think it could all of the physicists of the last 100 years be wrong?
Sure, anything can happen. I can be wrong. They can be wrong. I'm open-minded either way. I'm not conspiratorial either way. Einstein could be wrong. Everyone could be wrong. Look,
But is it something that we should be open-minded about, or should
why not?
we have a bias towards a particular opinion about?
No, I'm open-minded. Look, it doesn't make any sense. So, what Carl Sagan said, incredible claims demand
E-
incredible whatever evidence, right? So,
Extraordinary claims require extraordinary
yeah,
evidence.
you're making
Um,
you're
but we,
this experiment rejects logic. I mean, this is counterintuitive. So this is
yeah.
beyond extraordinary. So the least I expect is to see the experiment and not illustrations, not endless illustrations and endless animations. The least I expect is a reproduction, a video of somebody reproducing this experiment. I'm not asking for much.
Have you looked for papers in journals?
I mean, I just started looking, and there's not. I've looked for this before, and I know on YouTube there's very few experiments when it comes to quantum mechanics. There's very
Okay,
few.
but I didn't say YouTube. I said,
No, yeah, yeah.
journals, which is where scientists publish
Sure,
this
sure.
stuff.
But I
And
just
this experiment.
I don't like.
Can I say something?
Yeah, yeah, sure.
Listen. So if you're a scientist and you come up with a result, or you confirm a result,
Hmm.
for the 10th, up to the 9th or 10th time,
Yeah,
um, you publish in a scientific journal, and
sure.
then that gets your name in print, and it
Yeah,
furthers your career.
sure, sure.
And YouTube doesn't do that. But this experiment is so old. It's a century
I understand.
before YouTube.
You don't have
So all of the papers are going to be very old. They're going to be in libraries. They
you
might not even be on the web.
you don't
But
have.
the effect is, I believe the effect is real, and that it should be a part of other experiments
Fine,
that
fine. I understand.
people are doing,
I understand
such as
how.
quantum computing,
I
uses entanglement, for
Sure,
example.
sure. I understand how you feel, and you're apologizing for, for the fact that there isn't something on YouTube, which is fine. I understand. I'm open-minded. I'm just saying this is an extraordinary claim, so the least I expect is one piece of evidence. Just one. I'm not two, not three, just one. And right now there's zero.
Okay. It's not zero. It's just you don't know how to find it
Fine, fine,
because
fine.
you're not you because you
Fine.
don't know what you're doing
Fine.
in research and
Fine.
physics. You're looking on
Fine.
YouTube instead of where
Fine.
the physicists
I'm not
actually publish.
fine, fine. I'm not disagreeing.
What do you,
Just between right, it's between me and myself. At the end of the day, it's between me and myself. I'm interested in knowing. I'm curious about the universe. So I'm letting me know, and you can hear me telling me that this is an extra.
okay,
Mhm.
I'm not interested in hearing you talking to you. You understand that communicating is a two-way street, and if you
Sure,
respect the other
I
person,
respect
you
you.
will listen as
What?
well as talk?
What? You don't think I respect you? Do you
I
think
do not. No.
you think I don't respect you? After
I
we,
think you are disrespectful to everyone that I have heard you talk to.
why would you say no? I'm not. I'm not, and I respect you, and I respect everyone. I'm not. Look, I'm not saying Don Lincoln is lying or even he's wrong. I'm just saying show like extraordinary claims demand extraordinary evidence. I'm just looking. I'm not even saying give me extraordinary evidence. Just let's start with any evidence. I mean, you would think this is the most incredible thing ever in the history of ever to the power of ever. You would think.
Yes, it was really mind-blowing, and all of the physicists in the early 20th century wrote and complained about how counterintuitive this result was,
Mhm.
and how it troubled them, and they were pulling their hair out about it,
Mhm.
and it was nobody understood it,
Mhm.
and it was counterintuitive. And
Mhm.
these were smart people who would not easily be scammed,
I'm not
so
saying a scam. I never use the word scam. No, no, no. There's no scam. I'm not
I
saying
know, but
there's
but
no
you
scam.
you we
There's
we have
mistakes.
to ask.
I have to be
So
open.
there's an
Hmm. Go
but
ahead.
the extra it this is a counterintuitive result,
Sure.
but it is also an extraordinary claim to say all of the smartest physicists of the
Sure.
20th century
Sure.
were scammed
Sure.
about
I'm
something
not. I
that
didn't.
could
I
be
never.
verified in a
Never
laboratory.
said that. I never said scam.
I know, but that's the
No.
implication of
No.
of
No.
of
No.
there.
No. No. It's
Listen,
an
there
no.
there are two possibilities, right?
No. No.
One is that this experiment works as described, or it doesn't, and there's some other explanation
Sure.
that we don't know, right? Like
Sure.
it either works or it doesn't, right?
Sure.
But I mean, I don't want to risk a false dichotomy, but you know, this is a pretty clear result. So either all of the physicists of the 20th century were wrong about something that they were all paying a whole lot of attention to,
Sure.
and they had all of the resources of all the physics laboratories and the Manhattan Project and
Sure.
all this stuff,
Sure.
super colliders.
Sure. Mm-hmm.
Either they were all mistaken
Mm-hmm.
or they were scammed,
No.
Or
Why do you introduce
they
that
were
word? Why do you keep introducing that word?
because I don't want to dismiss out of hand the possibility that someone was fooling them.
No.
Maybe
That's very
maybe
unlikely.
alien life. Maybe
No.
okay.
No.
Have you seen Three Body Problem?
No. I don't watch. I don't watch it. I don't watch. I don't care.
It's a
I don't.
okay. It's a good book.
I don't
You can
read.
read it,
No, I don't read.
but you don't. Do you watch TV?
No.
Do you watch Netflix?
No. No.
No.
No. I
Okay.
don't like
So
input. I only talk.
you
And
don't
watch.
like input, right? This is clear. Yeah.
Stop. Stop being mean. Hey, Scott. Why are you mean?
It's
Why are
not.
you
I'm not
mean?
being mean. I'm
No,
simply
don't
explaining to you
say
the way.
don't be mean. Don't say that is clear.
I'm not being mean. I'm not
I
being mean.
avoid.
I'm saying that your behavior is consistent with earlier statements I have made.
Stop attacking me. Come on. You're better than this.
I'm not attacking you.
Yes, you are. Stop.
You go here every time we speak. I'm not attacking
Okay.
you.
Let's not waste each other's time. Okay.
I'm trying to have a. Okay.
No,
See you later.
No. I'm saying let's not waste each other's time by meta talking about each other. That's what I mean. I enjoy talking to you. I don't want you to leave. No.
Okay. So can we do just a little bit of meta here?
Sure.
Can you agree that if we're two people are talking, that maybe one person, like the amount that a person talks ought to be similar to the amount that the person is listening to the other person talk?
Sure. I'm listening. Yeah.
Unless it's like a teacher, a tutoring or
Sure.
teaching, thing. If it's we're
Agreed.
having a discussion,
Yes.
you ought to be
Yes.
listening
Yes.
in similar in proportion to the number of speakers in the conversation.
Yes.
Just basic taking turns. Okay.
Yes.
So let's try to do that.
Mm-hmm.
And when I'm speaking,
Mm-hmm.
try to resist the urge to say no, 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 stop, 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 and try to instead to listen to my words and understand my meaning. And
But
I promise I'll wrap it up. I'll be succinct, and then it'll be your turn.
what's the point?
Deal?
No. What's the point? What's
The point is
you?
taking turns, listening and talking.
Why?
And if
But
you can't understand that, I'm not going to waste my time with you.
what's the point in letting you finish if I disagree with the first word you said? What's the point?
So there can be a process for that. If you can't literally disagree with the first word that I say.
You said scam. I don't agree. You said aliens. I don't agree. Why waste the rest? Why let you finish the sentence? I don't think that that's on the table. That's very unlikely.
Okay. Well, okay, but I don't like. I believe in intellectual rigor, and I don't like dismissing
I'm not.
even extraordinary possibilities out of hand.
I'm not dismissing. I just told you.
You're doing it. You're
No.
talking over me while I'm talking. Do you hear yourself?
But I disagree with the first word. What do you want me to do? Let you finish?
Wait.
What?
Yes. Wait till I'm finished.
Why? What's the point?
I'll try to.
What's the benefit?
Because you might hear something and you might learn something and you might understand what I'm saying better instead of reacting quickly and reflexively and instinctively to a word. You might listen to my whole idea and decide, okay, I might disagree with 10% of that, but I agree with 90% of it. And it's an interesting discussion and we can sort it out with further exchanges.
Okay, but make it, please speak in short sentences so I can react and tell you. Okay, go ahead.
I will try to be succinct. I do not want to monologue.
All right. I'm listening.
Okay. So the reason I use the word scam is because we're in a flat Earth or a globe, Earth server, and we're practicing discussion that doesn't rule out possibilities. Like we literally have friends who think that all the scientists in the world are lying to us, or they are being scammed, or they're stupid, or something like that. And so I don't like to dismiss things out of hand in on this server. If I were talking with like professionals or something like that, I would not introduce the possibility of UFOs.
but I'm including that just for completeness.
Okay.
And I agree it's extraordinary.
Yeah.
But that's also part of my point,
Mm-hmm.
which is if we want to think of it in terms of two possibilities, one is the effect is observed and all of the physicists are sincere in this interpretation. And then the other possibility is the effect is the physicists are wrong about this in the universe, and the effect is not real. The first is an extraordinary claim, and so it's going to take. I think. Do you agree it's an extraordinary claim that Einstein and all the Manhattan Project scientists are just wrong about this basic
Yes.
thing that everybody was paying very close attention to? Okay.
Yes, and
that would be pretty crazy.
I
wouldn't it?
already agreed with that before the monologue. I already agreed.
Okay.
Either way, it's extraordinary.
Okay, so I don't like it when flat earthers say this, but do you think there's any credibility whatsoever that to when the physics textbook says this is a thing that is observed in the laboratory, and this experiment was these results were first seen in 1920 or something like that?
So
should we take that for granted, or
no, never.
you think it's probably true, or is it 50-50, or are the physics textbook probably lying?
No, no one is lying. So this violates intuition. This violates logic. Therefore, it cannot be true as far as I'm concerned. And the fact that there is no evidence is, right. I'm beginning to realize it never happened. If it did happen,
Wait. So you made an extraordinary claim. You said the fact is there is no evidence. What is that? Don't you think that's an extraordinary claim? Why would all these physicists and
no.
textbook writers say this and believe this if it is a fact that there is no evidence?
Look, I'm saying I didn't see any evidence yet, and what I'm saying is it could be
Okay. Do you see that's different?
Yeah, of course.
Okay.
Look. So it might be that something happened. And it was misinterpreted. Look, I looked into Michelson Morley, and I can explain it away. It's done. It's behind me. It's done. Michelson Morley, explain. Done. I have many papers. I've resolved many issues for me, between me and myself. I'm happy. Now the next thing is this entanglement. I've resolved basically almost everything else. So maybe I'll figure this one out. Maybe not. Maybe yes. I don't know. One thing I'm confident of, it cannot be true. So either it's a misunderstanding, because it can't be true. It's literally impossible. Because look, I'm assuming my assumption is this universe makes sense. In order for this universe to make sense, it must be mechanical. In order for it to be mechanical, there cannot be instantaneous communication. What? What's funny?
Yeah. So the universe, this is my belief.
Mhm.
My belief is that the universe is under no obligation to make sense to you.
That's fine. That's fine. So that's fine. So I'm starting from a premise. Like I'm just starting from an assumption. That's just my assumption.
And this tends to make people mad. This made the physicists of the early 20th century, Albert Einstein. It made them mad.
Okay. I'll try and fix what he couldn't figure out. Somebody's going to figure it out. Why not me?
Because you're not a physicist.
Uh,
You don't know what you're doing. You're terrible at this.
Stop. Okay, it doesn't matter.
Sorry.
I'm gonna just ignore your comments when you come after me personally. That's for me.
I'm not coming after you personally. You said, why not me?
Yeah, why not me? I'm asking.
That is, you asked about you personally, and
Yeah.
I'm telling you.
You don't know me. You don't know me.
I have spent hours talking to you, and I have some evidence about the way you think.
I don't care.
And some evidence of your qualifications.
Oh no! Stop!
and
Stop!
your
Okay, okay.
abilities.
No, man, please don't waste my time. Look, please stop it. Let's not talk about me.
Okay.
No,
We don't
let's.
have to continue talking.
No.
But you brought you up.
No, let's not talk about me. I said let's not talk about me.
Okay.
So
Okay.
all I'm saying is I'd like to see evidence. I'm starting now to look for evidence, and so far instantaneously I can report it doesn't exist on YouTube. So I'll keep looking. I mean, there is certainly right. I would have expected. Oh, a reproduction of the animation that we saw with Don Lincoln. Like, I would expect to see something like that. Somebody must have done that, and well, there isn't. Not. I haven't found someone on YouTube that reproduced it. So I'll look. I told you, according to my assumption, it can't be true. Just can't be true based on my assumption. That's all. But I'm open-minded to something. But my intuition is it's a misunderstanding, that it's possible to reinterpret, just like I've done this with everything else so far. I've done it with GR, with SR, with everything, with quantum mechanics. I've just reinterpreted the data to fit my priors, and everything makes sense, and I have a much better theory of everything at this point. I have quantum gravity. I resolved basically the particle wave duality. Like, a lot of the experiments that people claim are weird and they broke physics and broke brains, I resolved them. I'm perfectly happy with them. So
Okay. I think that's an extraordinary claim.
well, you can read my papers and we can
And
debate.
no, you have no evidence. No.
What do you mean?
You have an extraordinary claim, and you
Which
have
one?
zero evidence.
Which
What
claim?
you have is your own intuition and your own feeling of understanding, and that is not the same as an experimental data,
Sure.
and publication and peer review.
Look, I don't. I at this point I can't really publish and get my work peer reviewed. I'm trying. I talk to you, I talk to Tapioca Weasel and Dr. Park and Sea Line. Like, I'm talking to anyone who's willing to listen. I get abused 24/7,
Now you're talking about yourself.
Yeah, but you said publish and peer review. I'm doing the best that I can, as painful as it is, and it's very painful, and I'm paying a very
But that doesn't matter.
Fine.
Your feelings
But
about this don't
no,
matter.
you said
or how painful it is to you doesn't
no,
matter.
no, you
This is
said
not about you or anyone judging you.
no, you said no.
It's a question about the nature of the universe,
Sure.
which can be determined through experiment that requires a high vacuum
But
setup.
you said
Right?
not really. But you said that publish
Not
and
really.
no. You said publish in peer review, so I responded to that. About the pressure, the vacuum, there are people who reproduce Stern Gerlach at home. There's at least one video that I saw. A guy did it in Germany.
Who?
Some German guy did it.
I'd like to do it. I'm still working on reproducing, doing some basic, like Ampere's law and Lenz's law, and
Fine, that's nice.
I'm still a few hundred years back in
I
my
appreciate
home
I
lab.
I appreciate everything you do, and I appreciate that you talk to me. I appreciate you're curious. It's great. Look, fine. I mean, it's fine. Let me look into it. I'll come back. I'll report to you because I'd like you to know my progress, and I'll let you know. I mean, I just wanted to come here and just let you know. Like, if you knew, if anyone has conducted this experiment and has actual video of it, that would be nice. Or but fine. I'll start I'll start my search. It's fine. All right.
So I believe that my understanding is that quantum entanglement is an essential.
No.
Um,
No, it's not.
What?
It's not.
You haven't heard what? You don't even know what I'm going to
Oh, I'm
say,
sorry.
and you're reacting already.
I'm sorry. I okay. Go ahead. I'm sorry. I'm listening.
Okay, my understanding is that quantum entanglement is essential for the operation of quantum computers, and there is probably a ton of YouTube content on quantum computers, and some of it may discuss entanglement.
Mhm.
So if you have a working quantum computer and even a minimal one, and you can show that it relies on quantum entanglement, then maybe that would be to some degree useful for the experiment that you're looking for on YouTube.
So I
I'm just trying to give you a tip, a
yes, yes,
pointer
yes.
in a direction you might find interesting. That's all.
Yes, I agree. I've heard, and it would make sense that entanglement is good for quantum computing. I think quantum computing is nonsense, obviously. I listened to the Looking
It's not
Glass.
obvious.
Well,
Why?
I'm
Why
saying,
would that be obvious?
no, I'm saying since like I believe quantum computing is nonsense, but it doesn't matter. The
What do you
point
mean?
is, no, no, the point. Well, I don't believe there is superposition, and I don't believe in entanglement. I don't believe in, so I don't believe quantum computing exists. I mean, but that's not the point. That's not the point. The point is that I listen. One of my favorite YouTube channels.
Isn't that an extraordinary claim?
Sure, but hold on. So
Okay.
okay, okay.
You toss out these extraordinary claims and you cite as evidence only your intuition.
Sure, sure. Hold on.
Like you know this is a habit you have, right?
Oh, fine, fine. Hold on, hold on. I'm sorry. I don't mean to offend you, but fine. I'll try to be more. I'll try to be less obtuse about it. But my point is that one of my favorite YouTube channels is this beautiful Indian British chick. Her name is Looking Glass Universe or something, and she is a PhD.
I
She's
think I saw her the other day. Yeah.
yeah, she's
Yeah.
awesome. She's unbelievable. So she did her PhD in quantum computing. And I listened to her and she doesn't reproduce any experiments. All she does is animations, which is, it's
Didn't she do a double slit experiment
she
video?
failed.
That's the one I saw.
Yeah, she did the double slit with lasers with her hair strand. That was very nice. But
And she also did it with a double slit that she ordered from the scientific catalog.
maybe I didn't see that. But look, I listened to her and she's great. I love her. I love her channel, but I can't really say that I got anything from her. Like she was unable
But
to.
it did her
Mhm.
but her double slit didn't fail. She demonstrated it
She demonstrated
clearly.
that light is a wave. That the Young did this 1,000 years ago.
Okay.
We know light is a wave. There's plenty of evidence that light is a wave. That's not extraordinary. To show that light is a particle, that's extraordinary. So, but that
Yeah, she didn't slow it down to the rate of one photon at a time and
yeah.
do it over on photographic film.
What, however you want to do it, it's not simple, but
So she demonstrated the wave-like nature and not the particle
yeah,
nature.
yeah. There's nothing new about that. We've known this for a trillion years. I mean, at least since Young.
Yeah, which kind of misses the point of the double slit experiment, I
Yeah,
think.
yeah, yeah, yeah.
Yeah.
The whole point is to slow it down or use electrons or something else. So you could, but even the fact that a laser works when you know the theory of what a laser is, that in itself, it's a little bit that could help you understand the particle wave duality, the photoelectric effect. That can help you the quantum
How
scattering.
does a laser help me understand particle wave duality?
I mean, I don't believe in the particle wave duality at this point. So for me, it would be difficult to explain to you how it is because it's not. It's
So,
a wave.
do you believe lasers are real?
Of course, I'm just saying I can explain
Okay.
everything as a wave. I
Do
don't
you
need. I explain
do you
everything.
believe in that light is quantized
Yes, of
by
course.
frequency?
Yes, yes, yes.
Don't say of course, because you make extraordinary claims 1 second, and then you say pretend like I'm asking dumb questions when I ask,
No, I
just trying
never.
to figure out what basic physics you accept and what basic physics you
I'm
reject.
sorry. I don't mean to demean you. When I say of course, I mean of course. I'm not a flat earther. I'm not a conspiracy guy. I'm thoroughly up to date with mainstream. I agree with mainstream on almost everything. I don't use. You saw me. I listen.
Accept quantum entanglement. But you accept
Hmm.
lasers, but
Of
reject
course.
quantum entanglement, and you reject quantum computing. So it
Hmm.
so you can understand why I need to ask about
Sure.
specific things
Sure.
and not make assumptions about
Sure.
your beliefs
Sure.
of which parts of 20th century physics you accept and which parts you reject on the
Sure.
basis of your intuition.
Sure. You're asking? I'm telling you, I agree with almost everything that Neil deGrasse agrees, that Don Lincoln, Sean Carroll, all the big names, anything that is taught in university, I agree with. There is just details like entanglement that everybody agrees breaks the brain. So I just say if it breaks the brain, it must be wrong. That's all I'm saying. That's all.
So in like 1750,
Yeah.
um,
Hmm.
most of most you know,
Hmm.
thinking men.
Hmm.
I don't know if there were a few mathematicians, but
Hmm.
most thinking men
Hmm.
uh, did not believe in negative numbers. They just thought, you just couldn't subtract a larger number from a smaller number.
Hmm.
The result was nonsense or undefined.
Yeah.
Um,
Hmm.
and then 100 years later,
Hmm.
you had Maxwell
Hmm.
defining writing down all of the fundamental equations for um, electromagnetics,
Hmm.
field theory,
Hmm.
right? Like
Hmm.
that's the progress that happened in a little more than a century.
Yeah. Hmm.
And it's like
Hmm.
his progress in science is a history of people seeing something and thinking that can't be right. That doesn't make any sense.
Sure.
That doesn't fit with my mental concept of how the
Sure.
world should work.
Sure.
And sometimes it's a century
Hmm.
between
Hmm.
reach paradigm shifts, and
Hmm.
sometimes it's 3 centuries, and sometimes it's 50 years.
Hmm. Sure. Sure. Look, I'm open minded. For now, my priors are that the universe must make sense to me because otherwise I don't understand it, literally. It's
Okay,
like,
but that's not an argument. That's a fallacy.
no, it's an assumption. I'm presenting it as an assumption. It's an assumption I'm making about my life, about my, about it's
Okay,
just it's an assumption I make.
so what
Mhm.
if the universe could make more sense if you were willing to open your mind a bit more and do more
I used to.
listening and
I used to.
understanding, and without reacting
I used
and
to.
without placing your own into, like, just take your intuition and your presuppositions and put them on a shelf
I used to.
for 5 minutes at a time.
I used to.
you know
I used to.
okay,
And then I
and what
stopped.
happened?
Uh, wh-
how
Well,
did the
no, got me
how did that
nowhere.
work out for
Did
you?
not. But then I stopped. And then,
Really?
yes, yes, just the opposite. The day I decided to decide that this universe must make sense to me and I will not take no for an answer, everything started making sense. Every day you can follow me on YouTube, you can see the videos. It's every day I made progress. Every day something else made sense. Every day, every day. It used to not make sense, and now every day more and more and more makes sense. That's all. So far it's worked out very nice. I like it.
But you don't believe in quantum entanglement, so that,
Hmm.
like, you're at least 100 years behind modern physics, but that's better than most people. Most people don't grasp much of Newton.
I wouldn't say that I'm
Just
behind. I wouldn't say that I'm behind anything. I mean,
well, you are, because you're still stuck where Einstein was, not accepting, because of intuition, the results that were obtained in a laboratory.
yeah, I wouldn't say that I'm behind anything because I just wouldn't. That's not how I feel about my understanding. I'm not like I'm up to date. I listen you know to these professors explain things like up to date, like dark energy and everything. So I'm up to date on literally everything, and I can explain everything perfectly as far as I'm concerned. Well enough. It's just that I told you there's very few things I disagree with modern physics on, like entanglement, superposition, very, very few things. Like you can probably count them on 3 fingers, four
Ether,
fingers. Uh,
gravity.
I mean, okay, fine. I don't think I disagree with like my ether doesn't disagree with any known physics. I keep making that claim. Like, if my ether disagreed with any known physics, you please let me know. It doesn't. That's the beauty of my
Okay,
ether.
but it also doesn't predict
Oh,
anything
yes, it
that known
does.
physics
Yes, it does. It predicts dark. It
fails to
perfectly.
predict.
No, it predicts dark energy perfectly.
Sure.
What do you mean, sure? Why are you mocking me? It predicts.
I'm
What's
not
so funny?
mocking you. I'm just saying, like,
What do you mean? It predicts. It needs
I
with it. It doesn't work without dark energy exactly as we have discovered it to function. Exactly.
okay, that's not evidence that it's correct, though.
Of course it is. If that's not evidence, then I don't know what evidence is. That is amazing evidence that it doesn't, like, no one has dark energy so perfectly fitting their model. So I give you quantum. Look, it doesn't matter. Ether is behind me. I've it's good. I like it. If you don't like it, you don't have to use it. It's fine. I don't like. It's for me. I created the ether theory for me to understand gravity and everything else. If you don't like it, I'm not like it's yeah, the papers are published, the videos are available. You can take it or leave it. It's really I don't mind either way. I would like it's public knowledge. I give it as a gift. Whoever wants it can take it. But now I want to
No
figure
one
out.
wants it.
Stop being so mean. Come on, stop being
I'm
mean.
not being mean.
Yes, you
I'm
are. Yes,
telling
you
you
are.
the truth that you don't
No,
want to admit to
no.
yourself,
Stop. I don't
which
care. It's for
is
me. It's for me. It's for me. It's for me. It's for me. I don't care. I don't care. I
but
don't care. I
the
don't
truth
care.
that is consistent with all
It's
of the
consistent.
things
It's
that you
completely
tell me,
it's consistent.
the one consistent factor of everything that you tell me is that you do no experiments and you work with no observational data, and
That's
you
not true.
have no no peer review, and you are absolutely terrible at listening to other people who give you
Stop.
feedback.
Okay. All right. You're telling me that I'm terrible.
See, you're doing it now.
No, don't say that I'm terrible. Come on. You're a nice guy. You don't have to destroy the.
and
Come
and
on.
and then you make it about yourself, and you whine and you
No.
pretend you're being persecuted
Stop.
when someone tells you the truth, because you
Stop.
don't want to hear the truth, I think.
Stop. I don't want you to tell me that I'm terrible. Please don't do that. Come on, stop
I
it.
didn't say you were terrible.
Yes, you did.
I
No,
listed several
no,
specific things
no, don't do that.
that about your
Don't.
quest for knowledge
No, stop.
that
No. Come on, stop.
that might be
No,
helpful for you to
don't.
consider.
No, please. No. Let's talk about physics. Leave me out of this. It's not important. Please. Let's not waste each other's time. I want to talk to you about physics, not about me. Please. Let's leave me alone.
Okay. Okay.
So,
So next time you bring up you, I'll tell you we're not talking about you.
fine. Like all I said
So
is
let's have this conversation, and you're not going to say me or I
no.
or my.
No. Don't attack me. Don't tell me I'm. If like, if I tell you don't attack me, I said me, and now you're going to attack me because I said me. No, don't attack me. Like,
I'm
don't
not
talk.
attacking you.
Don't talk rudely
You
about
want
me.
to talk about physics?
Yeah,
Say
like,
something about
so
physics,
if I tell,
and then we will discuss
if I,
whether it is reproducible, whether it's a falsifiable theory,
okay, it doesn't matter. I
whether
don't want
it's
to
been
talk about.
experimentally reproduced.
I don't want to talk about ether. Ether. I'm done with ether.
Okay.
So
Okay.
we can talk about entanglement. That's right now what I'm curious about. Superposition is nonsense. That's behind me. It doesn't exist. Now I need to figure out entanglement. As far as I'm concerned, there's no evidence for it. I need to find whatever evidence there is and reinterpret it so that entanglement, the spooky action at a distance, goes away, and I'm done. And then I'll go figure out what else to do. What else is left to fix in modern physics, and I'll be happy. So that's
Well, I
the
hope
next
you can
step.
be happy. Have fun.
All right, man. Thank you. Thank you for the conversation.
All right.
I'll see you later.
Talk to you later.
All right.
Bye.
Talk to you. Bye. Oh my God. Why are people so mean? All right. 3 people watching. Why are there 3 people watching? Can you explain this to me? Oh my God. Oh my God. Okay. I got to run to the bathroom. I got to go wee wee. Wee wee in my panties. What about my panties? I need to put on my pink panties. So I was watching this guy, and that was a waste of time. Let me run to the bathroom, and I'll be right back. Let's post the bathroom break. The bathroom break. The bathroom break. Here is the bathroom break. There you go. Enjoy the bathroom break. All right. Now I'm hungry. I actually never ate, never had a meal. I gotta go eat a meal. So let me see what's going on. There's one person left over, one person watching. So let's see. No, on YouTube there is no evidence for entanglement. That is pretty clear. This is the most evidence there is for entanglement, and it's unclear what he's even trying to say. This guy is nothing but animations. Let's see this.
Here, we see a simplified representation of the experimental setup. The aim of the experiment is to produce pairs of entangled photons. BBO crystal. The crystal is optically birefringent. In this crystal, some of the incident ultraviolet photons create pairs of 2 photons, each having half energy and reverse polarization. That is, once horizontally polarized and once vertically. 2 polarization rotators, 2 polarizing beam splitters, a pair of detectors at Alice and Bob's side, respectively. Alice and Bob each define the respective vertical and horizontal measuring axis by adjusting their polarization rotators. A huge number of ultraviolet photons run through the BBO crystal without pair creation. Only with very small probability, pairs of entangled photons are created, leaving the crystal along the 2 red lines.
Yeah, I have no idea. This is interesting. Spin in quantum mechanics. Is this new?
This is the second video about
Yeah, this is new. She's like making long form videos, but there's no I don't care. Like she doesn't have
Here, we see a simplified representation
any evidence. I'm looking for evidence that quantum entanglement occurs. Like, okay, they're explaining the setup, but they're not explaining the result. Like, what do you want to do with this? Quantum visions, creating entangled photons. Okay, they're just talking about creating entangled photons, but show me that they are entangled. Like, what's your evidence that they are entangled? Like, show me the evidence that when you test one of them, the other one is always the opposite. So, evidence, entanglement, opposite spin. Show me the opposite spin. Yeah, animations. This guy is great with animations, just the best. Animations. Yeah. Great animations. Talking. Animations. Real-time imaging of quantum entanglement. Show me that you tested one and got the opposite of the other. That it's 100%. Show me that you get 100% opposite. 100% opposite. Right? It doesn't make any sense. Why should it be 100% opposite? How? Quantum entanglement. 6 minutes. Let's see.
Or wavelength that our eyes can see. If you could look closely enough, you'd see that the light comes in discrete. After the embarrassing failure of our hoax, the one where we tried to fool people into thinking our brains were quantum entangled, George and I needed to get out of town. So we decided to drive upstate to a physics lab where they observed, what else? Quantum entanglement. If we could see entanglement firsthand.
I don't care that they see entanglement. I want to see opposite spin. That if whatever you test one, you get the opposite for the other. That's what I'd like to see.
Our next hoax would be a bit more convincing. Our destination, the lab of Enrique Galvez, physics professor at Colgate University. Enrique has built a machine for his students to observe quantum entanglement directly. The apparatus may look complex at first, but don't worry, we'll break it down for you. It all starts with laser light. The color of the light is in the ultraviolet, which our eyes can't see. So what we're seeing is the fluorescing of the atoms and molecules in the card, fluorescing at the color or wavelength that our eyes can see. If you could look closely enough, you'd see that the light comes in discrete units called photons. These particles bounce off mirrors into a pair of crystals stacked against each other. This is the heart of the apparatus. Most photons pass right through, but every so often something special happens. An incoming photon gets split in two. The photons are polarized, which means they both oscillate in either the horizontal or vertical direction. The horizontal ones get created in one of the crystals, and the vertical pairs get created in the other crystal. And because the two crystals are so thin, we cannot tell in which crystal the pairs were born, and that puts them in this quantum mechanical superposition. When the photons leave the crystals, their polarization is the same. They're either both vertical or both horizontal, but it's impossible to know which. And in fact, the photons don't know either. Their polarization isn't determined until they're actually measured. That's entanglement in a nutshell. The particles' properties are linked, even though those properties haven't yet been determined. This is where a pair of polarizing filters comes in handy. If the photon is polarized, say, vertically, and it comes to a vertical polarizer, that photon will pass. Now, if that vertical photon comes to a horizontal polarizer, it will not pass. Now, if it comes to a polarizer that it is diagonal, and then let's bring this here. Okay, so then this is my vertical polarizer. I make it horizontal polarizer. But now if I put it at some diagonal angle, some of the light comes through. Okay, but now photons are indivisible. So it's not that half a photon comes through, but that half the time the photon goes through. If both photons make it through their polarizer, they're tallied by a counter. Physicists call these tallies coincidences, and they reveal an amazing thing about entanglement. When a photon's polarization is measured, the polarization of its entangled partner snaps into place in the same direction, even though the two particles aren't in contact. If we have polarizers that are parallel to each other, then they will be transmitted through the polarizers and we'll get coincidences. But if the polarizers are orthogonal to each other, then since the two photons are correlated to be parallel to each other, we don't get a case where both photons get transmitted, and so then we don't get any coincidences. Now compare that to the situation when the photons aren't entangled. Measuring one photon doesn't tell you anything about the other, so the pattern looks very different. Now when the photons are not entangled, then that is, they're independent of each other. So when they reach two polarizers oriented at these angles, then you have 50% chance for one and 50% chance for the other. So then if we measure coincidences, we'll get 25% of the time we'll get measured coincidences. But then since they're independent of each other, then whether these two are parallel or orthogonal doesn't matter. So then in this case, where the polarizers are orthogonal, we still get 50% chance that they'll go through and 25% chance that we will record coincidences. In other words, if photons are quantum entangled, they line up 100% of the time. If they're not, they line up only 50%, just by chance. So this experiment shows whether photons are entangled or not. Now think for a moment what entanglement means. One particle affects the other without anything passing through the distance between them. It's the closest thing in physics to real magic. It also really troubled Albert Einstein way back in the 1920s. He thought entanglement might be a sort of smoke and mirrors trick. It took nearly 40 years before Irish physicist John Bell devised a way to test both possibilities. He noticed that if you looked at the pattern of coincidences more closely, twisting the polarizers through various angles relative to each other, you could tell a cheat apart from the real thing. And lo and behold, he found entanglement is real. This tells us reality is not defined by proximity, something physicists refer to as non-locality. Non-local implies that the state of these two photons is joined. That is, that both photons share the same state. So that if we do a measurement on one photon, implicitly we're doing a measurement on the other photon. So then doing a measurement on one photon determines the state of both. And the Bell experiment tells us that our universe is way weirder than anyone, including Einstein, could have predicted. As we left Enrique's lab, the question remained, which...
What do you mean weirder? It's a violation of causality. What's the mechanism by which this works?
Seeing all this have helped George and me pull off our quantum entanglement hoax? Like everything else in the quantum world, the answer remains somewhat fuzzy and indeterminate. After the embarrassing failure of our hoax,
Oh, this is Scientific American.
where they observe what a bit more convincing machine for his speed. It all starts with
The molecules in the card fluorescing at the color or wavelength that our eyes can see.
If you could look closely enough, you'd see that the light comes in discrete units called photons. These particles bounce off mirrors into a pair of crystals stacked against each other. This is the heart of the apparatus. Most photons pass right through, but every so often something special happens. An incoming photon gets split in two. The photons are polarized, which means they both oscillate in either the horizontal or vertical direction. The horizontal ones get created in one of the crystals, and the vertical pairs get created in the other crystal.
I don't know what it means, what he's talking about.
And because the two crystals are so thin, we cannot tell in which crystal the pairs were born, and that puts them in this quantum mechanical superposition.
The fact that you cannot tell puts them in a superposition? Well, that makes no sense.
The photons leave the crystals, their polarization is the same. They're either both vertical or both horizontal, but it's impossible to know which. And in fact, the photons don't know either. Their polarization isn't determined until they're actually measured. That's entanglement in a nutshell. The particles' properties are linked, even though those properties haven't yet been determined. This is where a pair of polarizing filters comes in handy. If the photon is polarized, say, vertically, and it comes to a vertical polarizer, that photon will pass. Now, if that vertical photon comes to a horizontal polarizer, it will not pass. Now, if it comes to a polarizer that it is diagonal, and then let's bring this here. Okay, so then this is my vertical polarizer. I make it horizontal polarizer. But now if I put it at some diagonal angle, some of the light comes through. Okay, but now photons are indivisible. So it's not that half a photon comes through, but that half the time the photon goes through. If both photons make it through their polarizer, they're tallied by a counter. Physicists call these tallies coincidences, and they reveal an amazing thing about entanglement. When a photon's polarization is measured, the polarization of its entangled partner snaps into place in the same direction. even though the two particles aren't in contact.
It's nothing to do with contact. I mean, the particles need to know that we measure them. How would that work? I mean, this implies an intelligence. You're telling me that the particle becomes aware of me measuring it, and then it takes my measurement and it sends it to the other particle instantaneously, and the other particle can act upon the information about me measuring the first. There's so many unbelievable steps here.
If we have polarizers that are parallel to each other, then they will be transmitted through the polarizers and we'll get coincidences. But if the
Right, this is each one is 50-50, but he says no, it's coincident. If it's not, but this way it doesn't become, why is this not 50-50? According to you, this should also be 50-50. I mean, this should be 100%. This is 100% coincidence, and this is zero coincidence. Because let's say it's vertical, then it's 50-50. But if it's vertical, why is it not? I mean, if it's vertical, why is this not coincident? That's impossible.
the polarizers are orthogonal to each other, then since the two photons are correlated to be parallel to each other, we don't get a case where both photons get transmitted. And
why? So there's no coincidence. So let's say it's horizontal. But if we're measuring it the same way, then we get coincidence. If it comes in horizontal and we measure it in opposite directions, we get zero coincidence. Why? That doesn't make any sense. And the explanation has to be if entanglement is correct, it has to know that it's been measured. It has to know how I measured it. What do you mean snapped into place? I don't understand. What are we saying? I need to understand the story. You need to tell me the story. What is going on here? Even if I grant you instant communication, whatever that means, I don't even know. What do you mean by communication? So they say it's entangled. It's the same wave function. Since this one collapsed, that one collapsed. They collapse together. Mm-hmm. Andrew, what's up?
Yeah, how you doing?
I'm okay. What's up?
Yeah, I'm doing just fine.
Mm-hmm.
So,
Mm-hmm.
are you live streaming?
Yeah, and I'm thinking about entanglement. Mm-hmm. So entanglement.
All right.
Mm-hmm. What's up? What do you want to talk about?
Yeah, I'm listening to you. We can just continue with this subject.
Entanglement means two particles are entangled. Let's assume somehow, whatever that means, two particles, if they are entangled in quantum mechanics, they're quantum entangled. That means that if I conduct an experiment on one of them and I detect something about one of them, instantaneously I'll detect the same thing or the opposite, depends on the entanglement. But let's say they are entangled to be the same. So if they're entangled to be the same, whatever that means, so that means that if I do a measurement on one of them, instantaneously I know what the measurement on the other will be. Even,
Right.
but even, that's not the end. Even if the measurement, if I measured each particle, not entangled particle on its own, if I measured it, then the answer is a flip of a coin. So let's say,
Basically,
what?
right. So you're basically saying the tangleness or the tangle of the atoms would be a probability.
I mean, I don't know what you mean, but maybe. I mean, if you understood. So, oh, he's gone. Usually he doesn't come back. He has internet issues. So what he's saying is, let's try to go with what he's saying. So he's saying a single particle is entangled, and now it doesn't matter by how much we separate them. It doesn't matter how we separate them. If we measure both of them, and let's say they're both entangled to be horizontal, and on its own he said it's a 50-50 coin toss. When they're not entangled, it's a 50-50. It's 50% this, 50% that, 25% coincidence, 25% coincidence, which makes sense because each is 50-50. Okay, so this says that a particle can become two particles that are entangled, and then somehow they're entangled and they violate the speed of light. So they reduce the intelligence. They say we don't need to talk about intelligence. All we need, instead of intelligence, all we need to say is that they become described by a single wave function. And the wave function collapses when you measure it. So they have the whole story worked out. The whole story works out. Everything makes sense within their paradigm. They say, in this case, we're allowed to violate the speed of light. There is no causality. This has nothing to do with causality, which is weird. I mean, this is definitely weird. This means the universe. I mean, this is against the ether theory. I mean, I don't see how the ether is very mechanical. And up until now, everything until now worked very well with the ether. Everything has been resolved by the ether. So somehow what he's saying must be wrong. It's extraordinary. Extraordinary claims demand extraordinary evidence. So we need to see this. This needs extraordinary evidence. Can't just be a blackboard like this. What is your evidence? Fine. What you're saying is incredible, but this is too much. This is too much. This is too much. Not likely. Why is the server empty today? Hey. What about your PhD? So I made I so I offered you. Wait, Sea Line. What's Sea Line? Wait, Sea Line. We need to figure this out. Sea Line. We need to figure this out. Sea Line. Sea Line. What's this guy? When you're not here, he keeps steamrolling me. We Sea Line. Are you okay with this?
After I'm done talking to Morty.
Sea Line. Are you okay
Morty,
with this?
what can we do? What can we do, Morty, to stop you from what happened today?
Sea Line. Before you answer, this guy keeps harassing me when I'm on the server. I can't be here. He purposefully doesn't let me talk.
That is correct.
Oh, yes, my favorite entertainment time.
All right.
Wait,
Morty,
Sea Line.
maybe we can find you like a different hobby, man.
Sea Line, you gotta
Like
figure.
MMA or something.
Sea Line, you gotta figure
There you
this
go.
out.
Okay, your concern has been noted and will be raised with the moderation team.
Thank you.
So,
Hey,
Morty,
Piper.
you've accomplished so much with Flat Earth, man.
I know. I gotta just like step away, delegate.
We even, Jesse stepped up, I stepped up. We sponsored Miss Taylor to make her measurements.
Yeah. And now she's gonna look really bad if she doesn't do the measurements.
Yes, it is. This is what I
we
paid
will-
for, essentially.
And we will know if she doesn't do that and tries to pass off fake data.
Oh yeah. Also, we would love to have some documentation, like hold her up to her own standard, which is, film yourself, film the theodolite, all the stuff she demanded from Jesse.
Film the person filming, have a drone
Yes.
flying overhead that's filming the two people filming each other, and then have a satellite filming the drone. Just to make sure.
I would
hold
happily
up the newspaper from that day, a local newspaper.
I would happily pay for the oh damn, the word was right there. Sorry. I would happily pay for the notary republic to sign off on the observation.
Yeah.
Yo.
Hey, Showbill, by the way, congratulations on Flat Earth Friday. That was an epic performance.
Awesome,
and
yeah.
I have never seen that room, and I've been there too many times, more than I care to admit, in such a state of, it was shock and awe. What you did to them was shock and awe. Yeah.
Yeah, it was awesome. Alan,
Man,
I mean, you heard Alan, right, Peter? And his like
Oh, yeah.
bedraggled.
People are so terrible. Wait, I was gonna paste. I was gonna paste something. Oh, I did. This quantum entanglement. Never mind. So he's saying that if it's horizontal and it's entangled, we'll get 100% of the time. Hmm.
So then we don't get any coincidence.
Now compare that to the situation when the photons aren't entangled. Measuring one photon doesn't tell you anything about the other, so the pattern looks very different.
Now, when the photons are not entangled, then that is, they're independent of each other. So when they reach two polarizers oriented at these angles, then you have 50% chance for one and 50% chance for the other. So then if we measure coincidences, we'll get 25% of the time we'll get measured coincidences. But then since they're independent of each other, then whether these two are parallel or orthogonal, it doesn't matter. So then in this case, where the polarizers are orthogonal, we still get 50% chance that they'll go through and 25% chance that they will that we will record coincidences.
In other words, if photons are quantum entangled, they line up 100% of the time. If they're not, they line up only 50%, just by chance. So this experiment shows whether photons are entangled or not. Now think for a moment what entanglement means. One particle affects the other without anything passing through the distance between them. It's the closest thing in physics to real magic. It also really troubled us.
What do you mean it's the closest to real magic? It's ridiculous. It's beyond real magic. It's nonsense.
Albert Einstein, way back in the 1920s, he thought entanglement might be a sort of smoke and mirrors trick. It took nearly 40 years before Irish physicist John Bell devised a way to test both possibilities. He noticed that if you look at the pattern of coincidences more closely, twisting the polarizers through various angles relative to each other, you could tell a cheat apart from the real thing. And lo and behold, he found entanglement is real. This tells us reality is not defined by proximity, something physicists refer to as non-locality.
Non-local implies that the state of these two photons it is joined. That is, that both photons share the same state. So that if we do a measurement on one photon, implicitly we're doing a measurement on the other photon. So then, doing a measurement on one photon determines the state of both.
And the Bell experiment tells us that our universe is way weirder than anyone, including Einstein, could have predicted. As we left Enrique's lab, the question remains.
This. Mm-hmm. Mm-hmm. So the only evidence we have is a 7-minute video from Scientific American from 11 years ago. So maybe we should look at Bell's inequality, because Bell says he proved that it cannot be some hidden variable. But what would it mean for there to be hidden variable? So if it's horizontal, then it's 50-50, but it coincides on the 50-50. Either they're both up or they're both down at the same time. This is at the same time. This is not one after the other. This is at the same time. So it's not even instant communication. There's no cause and effect. There's no instant causality. They're both the same. Mm-hmm. Now, okay. Every time I get a glimpse of a little bit more of understanding. So there must be a hidden variable besides. So we can try and simulate this with a computer. So we can simulate a hidden variable that will resolve the test. So one thing is the angle, but the other thing is how we will react. So it's not flipping of the coin. There's no flipping of the coin. It's not that, right? There is no flipping of the coin. There is a causality. There is something at play here. This is not causality. This happens at the same time. It can't be causality because there's no causality faster than light. So there is no causality. We're not talking about causality. So it must be another variable. So can we create a computer simulation that does this? So we're going to add another random variable. So one thing is the randomness of in which direction it's going to spin, but the other is how will we react. But I don't want there to be flipping of the coin at the time, right? I can't have flipping of the coin. I need the flipping of the coin to be at the time of the creation. So at the time of the creation, I'm going to have a flipping of the coin that is true for both. That's going to give us randomness. There's another randomness. One thing is the angle, but one thing is the randomness. We need another random because we don't want because the angle needs to give us randomness. The randomness cannot be at the time of the test because then they're not entangled. In order for them to behave entangled, I need them to have another variable at the time of creation. Something during their creation, there's another variable besides spin. There's another variable. So we will create another variable and that's Bell's. So we will create another variable. There's going to be another variable at the time of creation. It's going to be another variable at the time of creation. And that is already, it has already the answer to the flipping of the coin. The coin flip is, the answer to the coin flip is at the time of creation, and it's going to be shared between the two photons. So they'll both have another hidden variable. That is the flipping of the coin. So they'll always coincide instantaneously. So I can simulate this. I can write a simulation for this test that gives me this result. That would be easy. A hidden variable would easily reproduce this. This is not an issue. So just to make a note, hidden variables easily reproduces. So hidden variable, a shared flipping of a shared random hidden variable predicting the result explains this experiment. So this experiment there's nothing spooky about this experiment. Okay, so the next step, World Health Organization. What? Why would I care about that? Good. All right, we made some progress. So the next step would be why can't I go directly to the chat? There's no way to go directly to his chat. Okay, here it is. So I told him and he never responded to this. So I can report the server. I could do that. Okay, I don't want to get upset. I don't want to waste my time getting upset, wasting my time. My life is too valuable. So this is simple. There's no issue simulating this experiment. This experiment is easy to simulate. The question is, can I simulate Bell's theorem? So the fact that they're entangled is easy. That's easy. That's easy. So let me just update.
ThinkPad, because when I boot, it still boots up real good, and it has some features that I can get nowhere else. And it takes a long time and says, copyright 1999 as it's booting, and it takes about 20 minutes to boot.
Go get coffee, make yourself some breakfast.
My son gives me a hard time about the fact that I have hard drives in my desktop. God knows what he would think about me if I had a DVD drive.
Oh, it's better than that. It's better than that. I even have a small hard floppy drive.
No way.
Way.
Wow. That's
How
crazy.
much did you pay for that? Like $1,000?
It's in the ThinkPad, which was a company cast off that I used for years and years, and then they decided I needed a new one. So, but fortunately, I got hold of a Sony Vaio, and now I have my my not Sony Vaio.
What caused the great?
You guys are nerds.
Initial cause.
Duh.
World War I did.
Hey,
That's why you're here, Peter.
I live and die for DOSBox, so I can still get a C prompt.
Just type CMD, Windows R, CMD, enter.
We're not just nerds. We're nerds with a plumb bob line and a side angle view with an altimeter.
DEL
That I can
space C
understand.
Windows sys.
Hey, Marsh, can you hear me?
And
Yeah.
and by the way, my second most favorite calculator is a Curta.
Nice.
I don't even
Hey,
know what that
Shubel,
is.
I wanted to just take you back to Flat Earth Fridays just very quickly. I heard you, and you were awesome, mate. And I've clipped Bakered asking you those stupid kind of questions about, I don't know, that somehow refraction doesn't work at beyond a certain distance.
Oh, that
was awesome.
10,000-mile observation.
Yeah, that one. That was just, yeah. And it's just great. You just eventually just had to say, I'm sorry, mate, but you're not making any sense.
But
Hey,
you know what's
so-
funny, Piper? I was listening to that live, and I think I know, because I know 100 crypto keys quite well. I've been listening to him for a year. He was asking a genuine question, and what I always do when I listen to them, I try to imagine what they're thinking, right? Because that's the fun part. And he was actually thinking that we think that refraction extends your kind of the distance of what you can see infinitely. So he was action. You cannot curve over like.
Anyway, I'll go eat. This I can easily make a simulation. Wait, I can easily make a simulation of this. This is not an issue. And the same goes for Don Lincoln. I can easily simulate Don Lincoln. So it's 50-50, but when they're entangled, the 50-50, there is an extra hidden variable that predicts it. So that's not a problem. So nothing should have bothered Einstein. That should not have bothered Einstein. There's a variable of a coin flip that is shared between the particles that we're not aware of it. We're not privy to that value, but that already predicts the result of the measurement. The measurement is predetermined. The measurement is predetermined. The measurement is predetermined. That's easy. The measurement is a coin toss, but it's predetermined already at the creation of the two particles, of the entangled. Entangled just means they share a hidden variable. Zabin says that there's nothing spooky about entangled particles. And Zabin said that the Nobel winner agrees with her that there's nothing spooky at Bell's theorem. Even if Bell's theorem is correct, that doesn't justify spooky action at a distance. Even without hidden variables, it's still not spooky. That's what she says.
Do black holes destroy information?
She has many videos in which she discusses entanglement.
Physicists have shown that objective reality doesn't exist. This is allegedly an
So she believes in superdeterminism. So all we need to understand is how does she resolve everything? She has the answer. So all I need is just to watch how she resolves everything and we're done. And entanglement is behind us. Okay, I'm gonna take a break. I gotta go eat. I'll see you later.